Okay, I think we're now live on Google Hangouts. Awesome, that's better than what we had. This is going to work. It's not working the way I wanted it to work. Oh, you know what? That would help. Device does not work when disconnected. There we go. There's not enough outlets, that's for sure. Now we got a screen.
Well, you could unplug. Is this a charger? Well, this would be a good place to have it because it's in the center. So
Yeah, I want to unplug something that's.
well, it's just a charger. It's a charger.
Yeah.
Oh. Yes, this camera is coming.
Oh, man.
Yeah, it's. I have it saved.
It's 700 NCONF, all caps.
Thank you very much.
There, I think that ought to do.
Devin, what was it again?
700 NCONF.
Am I writing that up there? So.
I would have been able to get set up, but no, not able to handle that.
Yes.
For you, I just. CONF. Okay. Oh, that's nice. So,
I know, right? Terrifying. So let's see over here. I'm trying to remember. Control room. Trying to remember how to give control. Ah, no.
So do we have the name of the Wi-Fi connector?
It should be 700N.
Yeah,
I thought there was a way I could give control to somebody else. How do I give control to somebody else? Okay. Hey, Alan, how you doing? That'd be better if I could figure out how to make this Google Hangouts on everything.
I had a problem with that at one point because there was not a link between my YouTube account and my Google Plus profile. I remember that being a pain. I feel like that setup is now easier than it used to be. You look like you're there yet.
So, we shall see in a moment. Can I share my screen is the next question. Entire screen share. There appears to be quite a delay.
Are you interneting on your phone right now?
Yes. Because I was afraid everybody would end up using all of the Wi-Fi. Oh, hey, maybe that's the problem. I wasn't presenting to everyone. No, that's just several minutes delayed.
Minutes delayed?
Yep. That's pretty bad. Well, now it's about 45 seconds behind.
Yes. I was about to ask you. Oh. Okay.
Not.
Yeah, 3.
Yeah, that's pretty badly delayed.
Is this your laptop?
My laptop? I'm old
Hands-on
school.
workshop.
I'm an old school guy.
Okay.
I'm actually very interested in this LDX too. I'm going to talk about that.
I have no idea what.
LXC?
LDX.
Oh, LXD?
I have LDX. Maybe I have. I'm a little bit dyslexic. Maybe I've read that. Not the alternative.
Well, LXD is part of the LXC project, the Linux Containers project.
Okay, so I must have wrote it wrong. See, so that's another reason. This is a.
So that's going to be about this much of the presentation,
Yeah.
but we will talk about it.
Okay. The.
Is that big enough for everybody to read? Should I bump up the font size?
I vote for yes.
Yes.
Yeah.
I'm gonna let you bump it up. It's a little tough.
How's that? No?
I just didn't think it bigger.
LXD. I don't thinking too much LSD, you know? It sounds more like LSD, and I didn't want to write that.
Really?
Is that?
Oh.
Oh. Well, there's a 45-second delay for it to show on the screen. Right now I've got it set at 32 point, which is probably too big for me to do anything useful with.
Yes. Yeah. That's great.
And in fact, we'll do this. Preferences, colors, text color black, background color white. Well, unfortunately, there is a pretty massive delay on the Google Hangouts on the screen.
Were you doing that so that you could drive from there and share from here?
Uh-huh. Well, that, and I'm also going to have Kenny, when he gets here, he's going to present some stuff too, so I wanted to just be able to transfer control to him.
Have you used Synergy?
Yes, I have Synergy.
If this thing has Synergy, you could just Synergy across. You'd have to watch that screen or this screen to know what's going on, but you can just use it as a monitor instead of going out through the net with that.
Well, that wouldn't help though, because I need to display what's on this screen.
Yeah, yeah, right.
Is that pretty readable, everybody?
Yeah. That font size is sure.
Okay.
Window titles.
The window titles don't matter.
Where am I headed, sir?
Hopefully Kenny will be here. He's supposed to back me up. I'll freely admit I am not the Docker expert of the world.
But using it a bunch.
Well, I use it every day at work. It's just a matter of,
Thinking, oh, these
I
chairs
probably
are-
don't know all the answers that people might ask, or for questions people might ask.
Right.
I'd be willing to get rid of all these chairs, actually. Put on the
Makes a lot of
sideline.
sense, yeah.
Redundant. I don't think I can run out of space really. This is kind of old school. I hadn't really thought about it, you know? No, I mean like writing things.
Oh,
on paper. I like to go and then rewrite it.
My papers, but I also have my laptop.
But I have a brand new laptop. I don't really want to use it. When I go into,
You don't think this is brand new?
I bought one of these for 25 hours. Just to have some.
And all the keys?
I had some keys missing. I use it pretty much. This mantra.
That's for all your psychedelic needs right there. Yeah, I just don't think that's going to work out very well, is it? Hmm. Yeah. All right. Here's what we're going to do. I'm just going to have to sit in the middle of the room, folks.
I've been working hard now.
Stay facing this way.
John, could you plug me in down there somewhere, please? Yeah, I am going to stay facing that way. No, no, it's the Google Hangouts delay is too long. I'd be doing something over there and you guys won't see it up there for like a minute and a half.
Yeah, that's not fair.
This is kind of cool.
So, sorry, John. Didn't mean to punch your laptop there. So, outputs, active. What's going on there?
No. No, not this.
Crap.
Okay, that's all I'm about to say.
Yeah, I'm gonna switch over to the HDMI connection. John, once again, my friend,
Fourth, Monday.
or Alan, either one.
And,
Yeah.
Nice panel that isn't screwed in. But the cable seems to be connected.
I don't know. Oh, okay, gotcha. Thank you.
dream about one of the 7,800 getting laid off.
Ooh, look at that.
Yes.
All right. Let's try this now. And switch the input on the monitor again. Hey, all right, folks. I think we are up and running.
You were following the pizza man.
Yeah, we were right behind it,
Yeah.
So it looks like both of my co-presenters have ditched on me.
Well, it's only 6:30. We have a half an hour social hour. We have pizza. We have to abide by tradition here. If everybody were on time, my gosh.
We'd have no time to eat
I
pizza.
think, who's your other co-presenter besides Kenny?
Just Kenny. Well, Brent Salisbury was going to show up from Lexington. He actually works at Docker.
I thought that was a joke. I just saw your post saying Brent might not make it. And then I Googled Brent and I saw, well, he was like the Docker man. And I thought you
Well, yeah. He actually works at Docker. He lives just outside of Lexington. He was going to come up and help out with the presentation. From his perspective, he deals mostly with Docker networking stuff. And Kenny is supposed to come and talk a little bit about Docker Swarm, which I've been unable to get running so far, though I have tried several times.
Hi, good. How are you?
And then I was going to talk about things like the Docker files, how to build Docker containers, Docker Compose, and a little bit about LXC, LXD, and those tools. So hopefully Kenny will still show up. For those of you that are watching online here, I apologize for the technical difficulties we've had getting set up. We are planning to start in approximately 30 minutes with the actual presentation. In the meantime, we're going to do introductions around the room as we normally do, starting with our gracious host, Mr. John Hicks.
Oh, well, thank you. I'm John Hicks. Yeah, we're going to go around and just quickly introduce ourselves. Just tell us something about yourself so that we can remember who you are, including your name. And then feel free to advertise, to tell us why you're here, what you're looking for, be it a job or to learn something or whatever. Just however you want to introduce yourself, really. Let's start up here with this gentleman.
Hi, my name is Daniel Armstrong. It's my first time here. I'm not a systems person, but I own a web development company, and obviously this is a big part of what we do. And we do have an opening for a systems administrator if anybody wants to talk to me about it afterwards. I wasn't intending on giving a pitch about that.
Fine.
I'm here to actually, learn something, meet people in the community. That's it.
Okay. Well, welcome, Daniel. And yeah, advertising is fine. We're here to network and work with each other. So.
Okay.
Joe?
Joe McNeely.
Hi, Joe.
Little networker here. Okay. Jeff?
Hi, I'm Jeff Squires. I'm a software architect at Cisco, and I get to work on a lot of open source projects. I'll be talking later.
Okay. Cool. Who's this guy?
I'm Alan Blunt, developer, playing with DevOps because it's fun. Very excited about Docker because I feel like it could really revolutionize all the infrastructure that I've had to maintain through Puppet or Chef or any of the other scripting tools. But the tricky part is tying all the pieces together. Playing with them individually is fine. Writing my own script to manage it is fine. But how to integrate those parts and pieces is exciting. So I'm looking forward to seeing what we got on that.
Okay. Let's see, Devin, do you want to tell us more about yourself?
Okay.
Okay.
I'll come around last.
Okay.
Introductions. Name, why you're here, who you work for, what you hope to get out of it.
Name, rank, and serial number.
Oh, I only have two. Josh Faith. I'm actually a middle school math teacher, and I just dig learn about this stuff. So.
Great. John?
I'm John, I'm retired, and I get to play most of the day. I'm kind of bored right now, so I'm looking for some new stuff to learn about Docker. Looks interesting to me.
Okay. Let's see, Cass?
Yes, Kaz Meyer. I'm currently on contract with Papa John's through our greatest host tech systems here, where I run the QA environment, basically sysadmin for the QA.
Okay. Very interesting. Let's see, we missed someone up here.
Chris Lynch, Senior Developer, HP. I know absolutely nothing about Docker, but I've heard great things about it, so I'm here to learn that.
Okay, Chris.
I'm Austin Sutton Davis. I'm here to talk to people what technical stuff they do. And I contemplate
Yes.
based on being able to make me a page on how to install something, but not follow the directions on the same page.
Mark McDonald, I'm a sysadmin with UPS. It's my first time here.
Okay, Mark, welcome.
I'm Michael Hell. I'm a ERP delivery lead, so I work at SAP and Oracle for Hewlett Packard currently. Also in the Code Louisville program, so I'm learning front-end web development and going to the back end in September. So
Very good.
Trying to change careers.
Anybody else here have experience with Code Louisville? Okay. Oh, good, Joe. Okay.
In case anybody missed it, there was actually a notice on NPR this afternoon that they are moving into a brand new purpose-built, refurbished building over on Market Street.
Refurbished.
Purpose refurbished, yeah. As part of the nucleus grants that they got, they're moving into a much larger space so that they can handle more students. It's been that successful. Yep.
Oh yeah, it's been very successful.
If you see one-on-one.
Oh, it's not NPR that's relocating, it's Code Louisville.
Code Louisville, yes.
Yeah.
Sorry. Continuing on with introductions before we get completely derailed.
IT security specialist, and I just got a new job recently. I'm contracting for Kindred Healthcare, doing risk management type work, and I'm here because I'm into open source. Been running Linux since, I don't know, 2001 or something, and I'm here to have fun with all of you people.
Good. Very good.
I'm Joe Mackey. I have an insatiable curiosity about databases and web development, so I'm here to expand my knowledge.
Good.
Outstanding.
John?
Yeah, I'm John. I'm a senior engineer at Nexus in the core services team, and just recently started coming into this meetup. So it's fun.
Good to have you, John. Jamie? Jamie.
I'll let him finish. I'm Brian Harley.
Jamie.
I do a lot of freelance sysadmin work, Active Directory, Unix, Linux. I'm not doing that. I teach at ITT Tech, Linux networking, physical networking, IP networking. There's a theme going. And I enjoy coming here. It's nice to learn different things from more experienced people.
Okay. Very good, Brian. Thank you. Jamie? You ready?
Hi, I'm Jerry Willis. I'm a software developer at Radiat. It's a software as a service workforce communications platform. Do a lot of iOS, Android development, C#, Ruby and stuff.
Okay.
I'm Nick Zaccardi. I'm an engineering strategist for Level 12 in Indiana.
Okay.
And then we're using Docker for our QA environments. So I figured out how to show up and actually learn how to use it.
QA but not production.
Yeah, QA not production, but while they're on, data will be in production in a month or so.
Right.
So we should actually learn how to use it.
Michael Litzy, I work at Norton Healthcare.
just recently switched from being a clinical application supervisor to now an AIX cache database admin the past couple of weeks. So I'm here to learn about Docker and hopefully also pick up some more high-level scripting information.
I'm Matt Willis. I'm a systems administrator since last meeting. My employer decided that I shouldn't work there anymore, and I've decided that really doesn't fucking bother me. I'm actually interviewing for Michigan in March. But I'm interviewing with my fellow geeks.
Okay.
All right.
Jason?
Yeah, I'm Jason Hubbard. I'm an applications recruiter here with Subsystems. I specialize in Java as local and national markets. I'm just here to learn and answer any questions you all may have about the Java market. I may not be a very good resource for the Microsoft stack, but if anything Java, I'll probably be able to help for you.
And Kason is our host tonight. We want to thank him for the meeting room, the facility, and also for the pizza back here that we're about to, that most of us have gotten a slice of. I'm ready to get one. Thank you, Kason, for hosting us. Who else do we have? We've got
Jim Troy.
Jim.
Troy, I'm returning here to learn this stuff.
Okay, and our next to last, Jim. I can't think of your name.
Dan Edmondson.
Dan, okay. Introduce yourself, Dan.
Systems administrator. Well,
Okay, okay.
just make it short and brief.
Hey, yeah, we've got.
Nate Mann, UPS Worldport. I'm a problem solver with 40 years of computer experience. I know, I only look 43.
Right.
Okay, Wes.
Wes Rice, I'm a solution architect with HP, actually for at least 2 more days. I just took a new role with InfoQ Coupon. I'll be the product owner for San Francisco, New York, and London coupons.
Very good.
Yeah.
Awesome.
Pretty cool. Pretty exciting.
And Jim here has
My name is Jim McCord, and I come from a manufacturing software background, and I just come here to pick brains and see what I can learn. I'm not actively working.
Welcome, Jim.
And last and probably least, my name is Devin Phillips, and I will be your presenter tonight. It looks like I'm going to be all by myself. The other 2 gentlemen who were going to help me couldn't make it. But hopefully I'll be able to answer most of your questions about Docker and Linux containers and lightweight virtualization. I am a senior software engineer for SumGuard Availability Services. In our cloud operations team, I actually use Docker on a daily basis. We run our dev, staging, and production environments inside of Docker containers. We deploy using Docker containers in a weird roundabout sort of way, but we do. And we coordinate our Docker containers across multiple hosts and multiple data centers. And I'll show you a little bit of some of the methodologies that we've chosen to use because of some of the early pain points of Docker. That said, I'm also the organizer of the local Java users group, which will be meeting this Monday. If you're interested at all in learning about Java, we'll be talking about reactive programming on Monday, basically discussing the available options for the JVM. So, that said, we have about 15 minutes for open discussion, but before we go there, I want to let everybody know we are doing a Google Hangout on air tonight. So if you could try to keep the chatter a little bit low so that we can keep the conversation understandable for the Google Hangouts. If you have a question or you want to have a discussion point, please raise your hand, and I will try to call on you as quickly as possible. But if we have people having side conversations, I'm afraid whoever's watching online will not be able to participate or understand what's going on. If you ask me a question, try to remind me to repeat it if I don't recall. I will try to repeat the questions so that they're audible on the Google Hangout. And aside from that, we will try to have as open a discussion as possible, but like I said, keep the side chatter to a minimum, please.
You recording too?
We are recording, I believe. How How do you tell if you're recording this thing?
I think that
It's
on the left-hand side, is there a little control box?
On the left-hand side,
One of those icons.
there's control room.
Hello.
Hello.
Hi! Whoa! Woo! It's like I'm dancing. That's how I always dance. Well, I believe that all public hangouts on air are recorded by default, so I hope we're recording. That said, we'll continue on. Does anybody have anything they'd like to bring up before we get started with the main content? I've told users online that we'll start the actual main content at 7 p.m. Eastern Time. So we have about 15 minutes to have some open discussion.
And pizza.
And pizza.
We have two people that have arrived since we began that need to introduce themselves.
Please.
Mike Payne, I'm a software development manager at Mercer.
Excellent.
Welcome, Mike. Let's see.
So, yeah, I'm Thomas. I just moved from Warsaw, Poland to Louisville.
Okay.
I used to be a software developer, then I became an agile coach, and now I try to be a software developer again.
Good.
And yes, I would like to meet new people, and I'd like to learn about Docker. I have small knowledge about it, a little knowledge, like broaden.
Good. Welcome. What's your first name again?
Thomas.
Thomas?
Thomas. Yeah.
Okay. And yours?
Mike.
Mike, okay. Mike and Thomas. Okay, doke. And I need to get some pizza before we go.
So also, for those of you that are interested, the password for the Wi-Fi is written up here. It's 700NCONF, all capital letters. And if you're interested, we also have a Q&A section on the Hangouts on Air. If you want to log on there and post your questions, I'll try to answer those as we go.
Sorry. Nobody else wants to speak up. I've got a silly question. I've been tasked with doing inventory at work while my boss is on vacation. And I actually have no idea what our network infrastructure is other than we have multiple mini switch routes. Does anybody have?
So the question was that you are inventorying a network that you're not intimately familiar with at all, and you want to know how you can discover and catalog all the devices on the network?
Yeah.
Depending on the infrastructure, there are multiple different ways to do it. If you look on, I think it was just recently released on GitHub, there is a tool that uses Cisco Discovery Protocol. Are they all Cisco devices?
No, it's, some of it's Cisco, some of it's HP. I've seen a few others.
So there's a thing called Cisco Discovery Protocol, and then there's LLDP, which is Logical Link Discovery Protocol. They're both implemented in most mainstream switches. And you can use those as a tool to discover the entire network using various different open source and commercial tools. I just saw a new open source released. If you check out Reddit's networking subreddit, there was a gentleman just discussing about this new Python script that he wrote that generates a network diagram from the CDP and LLDP discovery, and will actually give you iOS versions and serial numbers and things like that.
Oh, that's amazing.
Now, that said, if they're a security conscious company, they've probably blocked all of that or disabled it.
Or at least so talk to your version of her to work before you do this.
Yeah, there's 5 people in the IT department, 1 left, and the other one's on vacation. The other 3 are not going to sign.
The other thing you can try to do is if you can find the core switch and set up a monitoring port on it, you can plug Wireshark into that, and Wireshark can sniff your Cisco Discovery Protocol and your Logical Link Discovery Protocol, and you can output that into a PCAP, which you can then feed into certain tools. depending on how big the network is, that may or may not work. Finally, the last tool I would suggest is a tool that's from the olden days that may or may not work depending on how well it's firewalled and blocked off. It's called KYOSS NG. And KYOSS NG is an open source tool you can run on a Linux host that will go out and do a ping scan of your entire network, and then it will go out and inventory everything that it can find in the defined subnets that you make it aware of. And it will actually generate a network diagram. It will discover the operating system. If you give it SNMP community strings, it can discover all the information about your network devices via SNMP. By default, it will try public. And so, like you said, if they're not terribly secure, it probably defaulted to public.
Yeah, I was working on some of our Linux boxes and didn't have anything there. They had to do a ping sweep of the entire network, but did not have nothing pulled off.
So KYOSS will serve you very, very well then. If you can ping sweep the entire network from one location, you got no problems doing KYOSS.
What's really confusing me is it's a /21 subnet. It was under 200 devices on site.
Some people will subnet down like that to limit their collision domains if they expect the network to grow beyond the initial 255. So they won't go to a full /16 because they don't want to have such a large collision domain.
The one thing I found hard doing some inventory, I found that specific devices were on a different, whether it is before the final offer versus what the office stuff is on.
Mm-hmm.
Yes, there's some kind of, these are going to be this kind of device, these are going to be something else.
Sure. There's as many different reasons to subnet in weird ways as there are different network administrators.
Of course, our network administrator left.
How will Dockers fit with the IoT world?
The IoT? So the question was, how does Docker fit in with the Internet of Things world? Just like any other virtualization technology, you can use it to scale out your collection of information. You can use it very lightweight on actual embedded devices to segment applications on your embedded devices. So just as you would use virtualization anywhere else, you can use Docker as long as it's just Linux workloads.
Sort of. Windows is now supporting Docker. Windows 10 has got early releases for it, so that's changing.
By a virtual machine? Yep.
Right. So Windows is supporting Docker by creating a Linux virtual machine that you run Docker inside of.
In Windows 10, they're not supported. In fact, at DockerCon 2 weeks ago, they announced that they have cross-platform containers now. They can go between Windows and Linux. Brand new.
Is it running a Windows OS on the inside?
I don't know a whole lot about it. I just know that 2 weeks ago they announced that there's cross-platform.
Sounds like Microsoft has appropriated the Docker name and is putting something completely different under the hood.
No, actually, they announced it with Docker. So
I think they're trying to cash in on the wave.
They're absolutely cashing in.
Yeah.
Yeah.
But don't.
So,
Make no mistake, this is a huge
as we
impact.
go through this discussion tonight, you'll understand why I don't believe that Windows has Docker support, because Docker is built into the Linux kernel. It only works inside the Linux kernel with Linux C groups. Hey, Kenny made it!
Full house.
Yay! Kenny, you might want to come over here because if you're going to present, I'm going to have to hand you the HDMI cable.
I'll get some pizza.
Feel free. We've got a couple of minutes. Is it all gone?
Oh, never mind.
Man, that's what you get for being late, Kenny.
Late? It's not even 7 yet.
Sorry.
Yeah, but you do pizza and introductions at 6:30.
That's true. I forgot about that.
Welcome, sir. Hi. So one of my co-presenters did show up. Kendrick Coleman from Pivotal is here to help us talk a little bit about Docker. He's probably got quite a bit more experience with Docker Swarm than I do, which I was telling everybody earlier, I haven't successfully got to run yet.
Got some free stickers from DockerCon too, if anybody wants to.
Awesome.
Docker stickers with them.
Let's talk about something. We just brought up Windows and Docker. What they announced about it? I know you were there.
So Microsoft was there. Microsoft actually has a fairly big presence. You know, the whole .NET thing I think sparked a lot for this whole movement. I think they're kind of realizing that you know the VM virtual machine kind of the world is going to tailor off. It's going to happen, and so they're trying to be on the forefront of it. You know, there's been a few articles that have been published that it would make sense that Microsoft buys Docker because it would give them basically both gamuts of the entire spectrum, right? So that's one thing that's kind of been kind of speculated. That's sort of Microsoft's angle that they're going at it. They're already working on ways to be more Windows centric. Like right now, Azure is like basically like you can run Linux in Azure, right? Like that's what they're kind of pushing towards.
Mm-hmm.
So I think it's more Azure focused than it is like, you know, basically just doing everything on your desktop.
So I read something about, and wrote an article actually about cross-platform containers that they announced at Microsoft.
Yeah, I didn't read much about that, so I couldn't tell you.
All right. Thank you for your input, Wes. Much appreciated. Any other questions before we get started? We got about 4 or 5 more minutes to kill.
Is Docker open source?
So the question is Docker open source? The majority of the Docker ecosystem is open source. There are some commercial tools that people have created around Docker that are not open source, but the technology that it uses inside the Linux kernel, the C groups technology, is open source. The Docker layering capabilities are open source. The Docker manager, the Docker daemon, and several of the utilities that Docker themselves release are all open source and available on GitHub. Now, that said, a couple of commercial companies have come in around Docker and added a bunch of commercial tools that some of them you have to pay for, some of them you don't. So last month we talked a little about C-Sysdig. They have a cloud version of that tool that is a commercial tool for monitoring Docker deployments across multiple data centers and multiple infrastructures. There is a commercial version of Apache Mesos called Mesosphere that also integrates with Docker and Docker Swarm for doing basically orchestration of Docker containers across a large data center. There's a number of other tools like that. I don't really keep track of them because I don't tend to use commercial products.
I was about to say, I was like, I could show you I got a slide somewhere that basically shows a picture of, actually if you go to Mind Map Docker, and it kind of shows you the Docker ecosystem, just Google Mind Map and Docker. And it shows you the Docker ecosystem. Like it's massive, right? And the great thing that why Docker's gotten so huge is because it's open source. It wouldn't have gotten this kind of traction if it wasn't for being open source, because it allows anybody to contribute, allows the scalability, it allows anybody to kind of build what they want to be able to do, right? So as you see, these are all different products that plug into Docker.
So up here under security, we see Cloud Passage and SE Linux. Monitoring, we have Summitech, SignalFix, Sysdig. Miscellaneous, we have Zero to Docker and PowerStrip. Image registries.
So PowerStrip's like, that's, you don't have to read about all these things, but like PowerStrip's already been basically deprecated in Docker 1.7. That's why they have storage volumes and network drivers now in Docker. There's a company called Socket Plane that makes a product called Flocker that essentially allows you to build, if you're familiar with VMware, a vMotion kind of capability, but now with Docker to be able to move running applications from one server to another just in a container.
And this area is one that I'm particularly interested in, and I think Alan will find useful in the near future, is these tools that are built around virtual networking between Docker hosts. So Docker containers, you can have multiple containers on a single Docker host, and it's pretty easy for them to internetwork on a single host. But internetworking containers on separate Docker hosts is not yet a well-solved problem. And so that's what these products here are trying to solve. And I've actually used Pipework and Weave, and both of those are relatively usable.
Yeah.
Um,
one to talk about is Socket Plane. So Brent, who wasn't here tonight, that works for Docker, he was actually part of the 6-man team that was acquired by Docker from Socket Plane. So next time you see him, shake his hand. He's a fucking rock star. So if you ever get a chance. So Socket Plane is now embedded into the latest Docker runtime. What makes it cool is that you kind of don't have to think about networking anymore, right? Like he said, like networking is a challenge, and it's always been a challenge by saying like, I'm going to have a Docker container on one host, talk to a Docker container on another host, and have those links sort of work. That's always been a problem because of just the inherent nature of the networking stack inside of a Linux kernel. Now, what they've done is they've implemented microsegmentation and VXLANs into this now. So essentially, you can use, I don't know if you've gotten to Compose or anything like that, but you can basically create a swarm cluster, and then when you compose an app and say, I want to link 2 containers together, it automatically builds those VXLANs for you underneath of it, and you don't even have to think about networking anymore.
So for those of you
it's
that,
amazing what they've done in such a short amount of time.
to back up a step, for those of you that aren't aware of what a VXLAN is everybody here pretty much familiar with what a VLAN is? And how you can have in hardware configured about 4,000 some odd VLANs by default in
a virtual LAN.
Yep, a virtual LAN.
Area network.
Yeah. So VLANs are a layer 2 switching concept that allows you to kind of virtually segment your network into separate LANs. But large hosting companies, specifically like the company I work for, 4,000 some odd VLANs is not enough. So Cisco, in coordination with some other groups that were trying to solve this problem, created something called VXLANs, which allows you to segment even further at a slightly lower layer. So you can have your 4,000 VLANs, but underneath that you can have, it's 128 bits worth of VXLANs?
It's like 1 billion VLANs.
Yeah, it's several billion VXLANs, and each VXLAN can have 4,096 VLANs.
When is this useful?
In large hosting environments, when you have...
It's mostly for service providers and stuff like that.
Yeah.
Not so much. Even enterprises. Some enterprises can get there, but not terribly too many.
Yeah.
They're segmenting the human population in the matrix.
But what's great about this Docker ecosystem is that you basically have this native VLAN that everything works on, like VLAN 5, right? But now you can have segmentation between applications, right? So each Docker, 4 or 5 Docker containers can represent an actual application. Now having them talk over the same network without interfering with other applications is what gives you VXLAN, right? So that's what gives you that sort of segmentation.
So let's hold up right there and let's start at the beginning, because it's now 7 p.m.
Exactly.
It's now starting time, and we're going to start small and work our way up to more of the in-depth discussions that we were getting off topic on there. Yes, we have a question.
Yes. I believe, I think it sounds like we've got a wonderful program lined up, and really appreciate your effort. Jeff, I know, is probably prepared to speak about Ruby Python and GitHub bots.
Yes.
I just want you two to be aware of each other, and
I'll take less than an hour.
I don't know about you, but I know that my discussion could probably take 6 or 8 if we allowed it to. So it's up to you guys how deep you want to go and how much time we want to spend on each topic. If you guys are interested, we can let Jeff speak first to show off what he's doing with Sinatra and GitHooks, and then we can move on to Docker or whatever the group prefers.
Might be a good idea, because that way you're open-ended, and we can all leave, and you can just keep on going.
Yeah. I agree with this.
So I think what John's trying to say is I'm a windbag and can talk for hours and hours and hours.
That's different from me, though. Yeah.
You're welcome to use my laptop, or if you can plug in via HDMI, you're welcome to use the HDMI connection.
I don't have HDMI. I have the other two.
You're on Mac? I've got the adapter.
Oh, you got an HDMI adapter?
So, are you connected to the Hangout?
I am not.
Okay. If you'll connect to the Hangout, I will give you presenter.
Are there actually people in there?
There's two.
Oh.
They're marked as unknown, but
So that means really nobody.
could be. Could very well be.
I put some of the stickers I got at DockerCon on that table back there, so feel free to take some with you. Sorry.
Awesome. So without much further ado, we have Jeff Squires from Cisco Systems, who's going to be talking about integrating Sinatra with Git hooks for validating your commits and ensuring that they've been signed off.
All right. How do I join? I'm on your event page. Where do I go from
Just
there?
click the video screen.
Click that.
Mm-hmm. And then once I see you show up in the control room, I hope.
Martin, welcome.
Sorry, more technical difficulties. Oh, God, that cable's reached forever and a day. I do not see you in the Hangout yet.
Oh. Table flash. I say don't worry about it. Just I see yours.
So, that's interesting. Anybody know how to give somebody presenter on a Google Hangout?
Yeah, just start going. Ask Google now.
Okay, Google now. Actually, I've got my keyword set up different than that.
Goes to him, right? When he starts talking.
So, that's interesting. The lovely delay.
Oh, okay.
Anybody know how to give somebody a presenter?
There we go.
Yeah, he knew.
Fantastic. What is it? Just mute your.
I did. He did.
Oh, you did. No, it won't let me. Oh, because it's not controlled from my Mac anymore.
From the TV. No, it's speakers.
I was like, you probably muted it
Can you
from
mute
Hangout. You probably muted it from Hangout. There we go.
There you go.
Yeah, if you just mouse over the screen and
You gotta click something. Well, no, that mutes yourself.
oh yeah, that's true.
You both need
I do not see how to give you presenter there,
Alright.
Jeff. So
to lose.
I apologize for the technical difficulty. You won't be able to really see Jeff's presentation, but I'll do my best to let you watch it through my webcam.
It's a slideshow, doesn't matter.
Yeah.
Except the contrast is so bad that nobody's ever going to be able
No
to
one's
read
gonna
it.
be able to see that. Well, I'll put them up on SlideShare afterwards. Anyway, thank you, everybody. Hello, welcome. This is really just something I screw around with on weekends, and so I thought I'd put it together because it turned out to be, it was just a dumb project, and then it turned out to be marginally actually kind of useful. And so we're actually using it in some of the projects that I'm on, and I thought I'd share it. Now, I will disclaim this by saying I am not a Ruby expert, nor am I a Sinatra expert, so if your questions get too deep, I may lie. But first, let's cover a little bit of background here. Before I can talk about what it was I did, I got to give you a little background on what it is. So I think we all know what GitHub is, right? It's a popular web hosting service, right? And it's made for hosting all your Git repos, right? And you can be in various different projects and things like that. There's even an enterprise version and a free version where you can have an organization, and that organization can have multiple repos in there. You can apply policies to them and things like that, so you can do nice things by gathering together, a whole pile of repos and policies and teams and all these kinds of things. There's a bunch of other services on GitHub as well, right? So it's not just about pushing and pulling Git repos and things like that. They actually created workflows and lots of nice useful tools that are genuinely useful. Speaking as someone who uses them on a day-to-day basis, they are really great. But the one feature that I want to talk about tonight that they implemented is something called API hooks. So at various different stages in the Git workflow model, you can actually have GitHub do things for you on an automated basis, and that's kind of the key here. So the way that they do this is something that they call the GitHub webhook, and basically it's a way for GitHub to tell you when something has happened, right? So that's their little mascot there, the Octocat. So the Octocat says, hey, something just happened. But in terms of technology, more specifically, it's some GitHub server is going to do that, right? It's not some friendly little logo. It's going to be some server that calls out. And then even more specifically, what it's going to do is make an HTTP post call out to your server, right? And then your server can do something. And what it's doing, you probably can't read this in the back, but it's sending you a big blob of JSON, right? That's about what just happened. And it's actually a fairly large blob, a lot of metadata there that you can choose to act on. And so this comes into, what I showed you before. This is the, hey, something just happened, and then this, the JSON is telling you what happened, and you can choose what to do based on that. And there's a lot of different things that it can tell you, so a lot of different types of events. This particular event you can't see right here, but if you look at the slides afterwards, you'll see this is someone just created a pull request. Okay? So that's all fine and great, but why is that useful, right? What would you do with GitHub pull requests, or GitHub webhooks? The answer is whatever you want. There's a lot of different useful things that you can hook to automation. You talk to a lot of the people in this room, and you will hear, the gospel of automation, of making things work for you, because that's what computers are really good for. Plus, when you get a nice repeatable type of automation, it removes a lot of human error. It makes things go faster. It makes you more productive. There's a lot of good reasons to do these kinds of things, right? So the GitHub webhook is actually phenomenally useful in a lot of different ways. So here's a common GitHub webhook use, right? That someone creates a pull request and it sends out a post to your server, and your server actually kicks off a build saying, all right, let's test that code that someone just pushed up to GitHub. So we not only build it, but we also test it, and then we send the results back up to GitHub so that the developer who submitted it and the other developers on that project can say, oh yes, this was good, this was bad, whatever, right? And this is what it looks like. So this is a pull request. I'm just showing a snippet because it blows up well and there's too much detail to show on a slide to a large room. But from a pull request that I did on GitHub earlier this week, I think, where I pushed this commit, and what it did is it actually kicked off 3 different builds, right? So one is at a Los Alamos Cray machine, which is actually in California. Another at a Los Alamos machine that's actually in Indiana. So, they lie. It's the government. And this one here was in Israel, actually. So it kicks off these 3 builds to test that code that I just did. And the cool thing is that these are all completely fundamentally different environments, right? So part of this open source project that I'm on, the fundamental strength of it is that everybody has different hardware, different operating systems, different environments, different setups, all these kinds of things. So this is a particular type of test. These 2 are very similar tests, but in very different environments. So it's actually a fairly nice smoke test. It's not an exhaustive test. It's not a system test. It's a good smoke test to make sure that this code isn't going to break the build. And then, lo and behold, a little bit later, the text might be a little small to read in the back. It says 3 successful checks, and all 3 of these turn green, and I get a nice green check mark. And it also says the git commit with this hash, passed all the smoke tests, right? And so that's actually a fairly common use case. You see a lot of this on GitHub. It's very useful. But let's look at another use case. I was actually just looking for an excuse to go screw around with Ruby because all my colleagues tell me that all the kids are playing with Ruby these days. I'm a Perl kind of guy myself, but I figured I should go expand my horizons, go look at a little Ruby. And so I was looking for an excuse and something to do with it. So another little background. This is another open source project that I work on called libfabric. It's part of the Open Fabrics project, or the Open Fabrics Alliance. It's about a next generation, very high performance networking stack. So it's you're familiar with TCP/IP and sockets, it's totally different than that, even though it's over the same layer 2 and layer 1 networks. It's an OS bypass kind of things. It's used for very high performance computing kinds of things. This is what I do in my day job. And so we keep a lot of our code on GitHub, and we're a multi-organization development group, right? So there's Cisco, there's Intel, there's Cray, there's Los Alamos, there's a bunch of others as well. And so it just makes sense to have it all on GitHub there. And well, one of our rules is that we have to have signed off lines on there. So right, for every commit, you see a little signed off by blah, blah, blah at the bottom there. But oh, look at this guy here, nasty guy, forgot to put his signed off line, right? And so these are the types of things that we want to avoid, right? It's kind of stupid, but it's, for a variety of reasons, still kind of important. And it's just a dumb thing that somebody has to check for, or we have to notice, and then yell at somebody, and these kinds of things. Now, another key point in the story, still in the background here, is that libfabric only accepts incoming code as a GitHub pull request. Now, let me explain a little bit about what a pull request is. I mentioned this earlier in the presentation, but I didn't really give a definition of it. So what a pull request is so this is the main repository for libfabric, right? So on GitHub, my user, I will say, hey, let's make a fork of this. It basically makes a clone of it, but it's under my control. I can write to it. I can read to it. It's, I'm basically, making a fork of it, right? Second step is that I make some kind of commit on my personal repo. Notice I've got a good signed off line there because I'm a good, responsible developer, right? So I do something very important, which was actually, was that last week? Yeah, it was last week. And then I file a pull request, which basically, opens a ticket up here on the main Git repo, and it says, hey, Jeff Squires would like to include this commit up in the main repository, right? So then the last step is that one of the libfabric maintainers says, oh, okay, that's cool. I will pull your commit, and I will put it up here in the libfabric GitHub repo, right? So it's basically a way for this whole social coding ecosystem to work, right? You put your code publicly, you let people examine it, and if they like it, they pull it up into the main repository. Now, I did miss a key step in there, though, right? The missing step is words, 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 words. Somebody's got to review it, right? Someone's got to make sure, is this code that we want? Is it good code? Does it break things? Does it fit in with the rest of the code? Does it pass all the tests? Does it do all of these kinds of things? There's all these things that coders like to worry about, and then the dumb things that coders don't want to worry about, like, is there a signed off line, right? So, like I said before, it's kind of a dumb thing, but it's unfortunately kind of important. And it's important because the lawyers have told us that we have to have it. And so if we don't have it, they get very mad at us, particularly because we work for big corporate entities, right? So more specifically, it's something that we have to have, but I want to spend absolutely zero effort making sure that it's there, right? So this fits exactly into the mantra of automation, right? I just want to have something yell at me when somebody forgets to do it. And it doesn't have to be a human. This is a thing that is perfect for a computer to do, right?
Question.
Yes?
Can it be a human, and where do I sign up for that job?
I would love to see your commits on the GitHub repository.
No,
we will pay you the $0 salary that it gets.
I will physically yell at people.
Well, unfortunately, we are distributed all around the world, so it's hard to yell at everybody.
It's okay, I'm loud.
You will email MP3s. That's fantastic. All right, so perfect job for automation. So let me show you what it does, and then we'll go back and look at the code briefly here. So here is a pull request with 3 commits on it from one of my colleagues here at Cisco. You see he did 3 different commits, and it actually kicked off the pull request signed off line by verifier, and you see it put 3 little check marks there. It gave me a check mark saying, hey, all the commits were signed off. Yay! Right? And this all happened completely automatically. Now here's another example of one. This is a fabricated thing here. So I did a pull request with a bunch of commits here, and I did not sign off on it. You can see I put right there. I did not put a signed off line in there. So the verifier, says, oh, there's a bad commit, and you get a big red X there as well. Okay. Now, some of you may have noticed. What about this one? Right? This one, I specifically did sign off this one, but it got a red X. Why? Well, it's actually kind of a quirk of GitHub. The GitHub sets the status of the entire thing based on the last commit. So we have it say if any of them are bad, then make the last one be bad too, because then Git will show an overall failure for that whole pull request. Okay? Because in our requirements, we want them all to be signed off, not just the last one, and not just some. It's got to be actually all of them. All right. So that's what it does. Let's look what it is. All right. So first off, there's Sinatra. And Sinatra is sinatrarb.com if you want to go have a look at that. It's an open source technology. It's basically, I stole directly from their website. They say it is a domain-specific language for quickly creating web applications in Ruby with minimal effort. Right? And they gave some very quick examples here. Basically what it is, it's a framework, and it's kind of Ruby-esque in that it basically helps you do web applications doing very, very little things. So it's a gem. You can install it the usual ways, and then you run with Ruby, myapp.rb kind of thing, and it just launches in the background. So let's look at the logistics of that. Assuming that you've written some kind of Ruby thing like myapp.rb, you just run it, and it opens up a port on your local machine, 4567. So you can connect to it with a local web browser like so. Okay, and then you are talking directly to that app. And so if you change your script and hit reload, it all just happens automatically. It's very nice. Now, in a remote kind of way, you can have a server running, right? You can have your Sinatra process running and your Apache web server here that reverse proxies to it, right? And then a remote, Firefox browser or whatever can come into, the normal way, and the server will talk to Sinatra in the background. And if you're at NGINX, all good, whichever way you like, right? Does that make sense? Right. So same kind of model. You can just put a web server in between, so you can make it remote as well. Right. So how does the signed off? How does this all fit in here? Right. So I wrote this code in a Sinatra little script. It's not very long. I'll actually show it to you shortly. But basically, what it does is when the GitHub server say, "Hey, a pull request was just created or modified." Right, so I want to check it every time somebody does something to a pull request. It hits my server, and instead of kicking off a build, it kicks off my Sinatra guy that says, hey, does each one have a signed off line? And then it sends the results back to GitHub. Right? So more specifically, like so. Right? And then Sinatra sends back to the GitHub servers what the results are. Right? If you want to look at the script itself, here's where it is. That's a giant blob in itself, so here's a slightly easier way to find it. If you go to this GitHub project, OFIWIG libfabric, go to the config subdir, that subdir, and there it is. I was heavily inspired by the Pro Git book. They have some Ruby Sinatra examples in the back. That's how I started going down this path. So my script started with their examples and then went heavily from there. So now I'm going to shift here and show you. There I am. Sweet. And one of my colleagues is pinging me right now.
Hey Jeff, it's 2015. Emacs needs to die already.
No. Emacs is life. But I will make things significantly larger for everybody here. I actually have this in the slides, but it is much easier to read this way. Okay, so it's also nicely syntax highlighted this way. It was a real pain to put it all in a PowerPoint slide. All right, there's not a whole lot more, and I want to give a lot of time back to Devin here. So let's just start. A couple of requisite require statements up at the top, right? So they're kind of, for me, the C systems developer guy, they're like include files, right? The first one I found was not, it took a lot of documentation to find out. That's required on Red Hat 6. So I work in enterprise-grade Linuxes, sometimes kind of old ones. This is how you import your gems on Red Hat 6. I use the HTTP party class down below, you'll see. Sinatra is how you bring in all the Sinatra functionality, and then I use the JSON stuff to do all the parsing and creating and parsing of JSON stuff. Fun fact, So I showed a slide earlier where it said the Sinatra defaults to port 4567. You can set it to whatever you want. I put this in here just because I picked one. I wanted it to be on 5000, and it seemed like a good example of leaving that in there. Flatbed is the name of the server that we run this on. So here's just a global thing. I'll use that later. And then there's another bit right here. So when you send results back to GitHub, they need to be authenticated, right? And I certainly did not want to hard code some kind of token or password in this script in itself. So I actually pass it in an environment variable, and this checks. It says, hey, go get that environment variable, and if I didn't find it, then just exit, saying, hey, you didn't give me the authentication, so I'm just going to bail. Right? But this allows me to put the whole script up on GitHub without putting my password and my token up there. Now, the syntax for the Sinatra applications is actually very simple. So if you look at this right here, it just says, oh, if somebody does an HTTP get of /, return that string. That's it, right? So it's a 200 HTTP status and just that string. So very boring web page. But I did this per the comment right up here. GitHub does its webhooks via posts. And so this is where the real interesting stuff is here. But if you don't put something for the get of / and somebody just visits it with the web browser, you get this goofy Sinatra error message. And I was like, no, forget it. I'll put a goofier error message. I don't know, whatever. But I just wanted to have something there. But then by the same token, so if you look down here, when someone does a post to / execute this code. Again, very simple, very easy. It was actually kind of fun to do that. So the first thing we do is we just parse the JSON. And it makes me, who's a Ruby person here? What is that called, a directory or a dictionary?
Which one?
This kind of variable.
It's a hash.
It's a hash. Okay, it's a hash in Perl. I don't know what it's called in Ruby.
No,
Well, it's
not called the
multidimensional. It's based on keys.
It's like a dot notation.
Yeah. Okay. So it gives me the JSON that came in from GitHub, right? With all that metadata. I showed that orange box earlier, chock full of all the metadata and stuff like that. So I get the repository name, and I check. Is this one of the actions that I care about, right? Long story short, I care about the synchronize action and the open action for pull requests. And if it's not one of those, then just bail nicely, right? So return a 200 status and this string, and that bails right out. Okay, now, when I get the JSON for this action, it's going to give me a list of all the commits that occurred on this action. So say a developer pushed one more commit. I will get JSON describing that one more commit. Or they rebase and replace one or more commits. I'll get JSON for all of those new commits. But I actually want to get all the commits on the pull request because I need to check and make sure that all of them are green so that I know how to set the last one there. So I actually need to do an outgoing request to GitHub and say, hey, I want to know, the status, or I want to see the commit messages for all the commits that are on this pull request. So I create a simple JSON thing right here, and I do an HTTP party get with just those. I'm sorry, I said that was JSON. I totally lied. It's just those headers right there, and it dumps it back into this hash or dictionary or whatever it's called. Okay, and if I get nothing back, just do a quick sanity check. Because periodically I found that GitHub failed on me and I got some kind of error. It says, oh, hey, there's no commits, and it just returns a 200 or so. Right? Then we go through and we basically iterate over them. Right? And we analyze them and we say, hey, do I like these things? So this is the syntax for basically a loop, right? I'm saying over all the commits that I got back in that hash, go look at them and do a quick regular expression and say, hey, if I have a signed off by in there, that's enough, right? And I say, oh, okay, that guy is happy, this commit is signed off, okay? And if not, I say, oh, the status of that particular commit is a failure, red X, as opposed to a green check. This commit is not signed off, okay? And I also say with global here, saying if any of them are bad, I say that happy equals false, right? And I set the last message, final message, to be this message, so that when I get out of the loop, I have this global called final message that was the last commit. Okay? And here, if I'm on the last commit, I say, you know, if I was happy, meaning that all of them went through and they were all signed and happy was still true, great. I say all commits were signed off, yay. You saw that in the picture earlier. And if not, it says at least one commit was not signed off, right? And then the final message equals that thing right there. Okay? And then I post that back. Again, very simple. Just HTTP party post, give it a couple headers, and this array right here, I convert it to JSON, send it back, fairly done. Okay? Didn't go into a huge amount of detail here, but the point is, it was actually, who know nothing about Ruby, I knew nothing about Ruby, but I did this basically in an afternoon, right? And I made actually a useful service that is now running on our open source projects, saving people nanoseconds a day. It's wonderful, right? That's it, actually.
Very good.
Any questions?
SinatraRB.com.
Yeah. Sinatra RB.
Actually, Sinatra has been so successful that it's been emulated in other languages and frameworks. There's Sinatra-alikes for languages like Java, Python, so on and so forth. Oh, all right.
The main attraction.
I don't know if it's the main attraction, but it's the one I'm concerned with. Oh, you know what? I'll bet it turned off my other display because I unplugged it. There we go. I got it? There we go. So, what we're gonna, pardon me. What we're gonna talk about tonight are two particular things. Based on one particular piece of technology. So in the Linux world, back in kernel 2.6.24, wasn't it, I think? They added a feature that was inspired by old mainframes. Old mainframes had what they called logical segmentation or logical containers or logical zones. When you're talking about like the old Z-series IBM mainframes or the AS400s or the RS6000s and things like that, they had this ability to create separate areas inside of your computer that were isolated from other areas of the computer so that two people's different programs that were time sharing wouldn't interact with one another. They brought this concept into the modern Linux kernel in the form of what's called C groups or container groups inside of the Linux kernel. So if we step back and look at it from the point of view of virtualization, a lot of you here are familiar with tools like VMware, VirtualBox, Zen, so on and so forth. They allow you to run multiple virtual computers inside of a single computer. The ideal there being making best use of your hardware. You can more completely utilize your resources if you can create multiple virtual machines with isolation. You can run multiple operating systems, things like that. The problem with that is a lot of workloads these days are all just on Linux. You know, a lot of hosting and enterprise and server applications, they don't need a different operating system than the base operating system. And by adding that extra layer, you're using more memory, more CPU, more I/O, and you're bogging down the system a little bit. So C groups removes one layer of abstraction. You use one single operating system and you use logical separations within that operating system to create these containers. The initial implementation that used containers was called LXC, or Linux containers. So LXC is the main project. I'll zoom in a little bit here. And what LXC does is it allows you to use their command line tools to create an isolated process area for an application on a Linux machine. So within LXC, you can say, allow processes running inside of my container to use these resources on the host system. You can give it access to files, to network interfaces, to a certain amount of memory, to a certain amount of CPU utilization, certain number of CPU cores. And what it does is it creates an isolated process space, so everything inside the container has its own process IDs. It creates an isolated network space, so everything operating inside of that container cannot access what's happening network-wise outside of that container, except as you would from host to host. It actually has to go kind of out on the wire and come back. So it can't monitor everything that's happening outside of the container. And finally, it creates namespace isolation, which allows you to generally set separate host names, to set separate environments for the operating system itself, various different things like that. Now, LXC, unfortunately, is a little difficult to use because you have to specifically allow every resource that you want to use inside of a container. So if I need to be able to use these 60 libraries and these extra files and this file system, I have to explicitly allow that in each LXC definition. Now they've got tools that make that relatively easy. You can actually run a process inside of an LXC monitor, and it will tell you everything you need to allow inside of your container when you define it. But that's kind of a pain in the butt to set up. So somebody had the bright idea, we're going to make containers easier. And along comes this company called Docker. And what Docker did is they simplified this by saying, we're going to package our own file system with our own libraries and OS level stuff so that you don't have to worry about manually adding everything from the host OS. Plus, you could actually use different sets of libraries than what are on the host OS very easily. This has some benefits in that it's easily repeatable. You can distribute the whole container very easily to other people. It also has some downsides in that it uses a lot more disk space, but we all know disk space is pretty much free these days, depending on which cloud provider you're using. And it's the containers that you package up are huge. They can be huge. So think of LXC as an even lighter weight version of Docker, kind of a pain in the butt to set up, but still very powerful. Docker is built on top of those C groups that LXC uses. It even uses some of the LXC libraries to build these packaged containers that are nice and easy and manageable. That said, the basic gist that you need to understand, the difference between Docker containers and a virtual machine is lower overhead, similar levels of process and isolation, process and memory isolation to a virtual machine, and it's can still help you use more of your resources efficiently on a single machine by creating these separate containers. So let's stop there. Questions, confusions, differences between containers and virtual machines. Does everybody kind of get that concept now?
Mm-hmm. Does everybody understand why this is important? It's okay to raise your hand if you don't.
Well, I see one is prioritization, so you can give one of these Dockers a lot of power if you want to, and have whatever sitting in the background getting less power. The other thing is that how do you connect one Docker to another virtually network device?
We'll get to that. We'll get to that. And that's specific to Docker. I'm trying to make sure you guys understand the difference between containers and virtualization. And to Kenny's point, the main reason is if you're wasting resources running all these extra operating system layers on a virtualization platform, that's electricity, heat, memory, and CPU that you could be using to run applications. and you could get your application density higher than it would with regular virtual or hypervisor style virtualization with Docker or container virtualization. You can cram more applications into less hardware. That's the bottom line. That means our profits go up, our shareholders are happy. That's really what it comes down to.
And you're green.
Super green.
Well, you're more green, but
Yeah.
I don't think anybody's reducing data center size. They're just cramming more applications into the same space. Those data centers are going to continue to grow for years and years and years, I think.
And so, other thing to understand that this is an infrastructure tool, right? But this is also something that you've probably heard the term thrown around by us in the threads, like the term DevOps, right? And why this is so critical to this movement is the fact that there's always been a disconnect, right? Like developers say, oh, it works on my laptop, and then you give it over to production, and then just shit breaks, right? And then there's a bunch of finger pointing. Who knows why it's not running correctly, right? So as you can see, it's build, ship, and run it. So the idea is that a developer is able to test his application or her application inside of a Docker container, and then be able to take that container or be able to take this file that's basically a DSL of how the container is built, hand it over to production, and just say, here you go. This is going to work because if it runs here and it works properly, it's going to run over here and work properly, right? So it's sort of starting to bridge that gap between developers and the operations groups.
Mm-hmm. So about Docker and how Docker works is that Docker creates typically layers. So you start with an empty Docker container that has nothing in it. It just has CPU memory and a storage resource that Docker gives it. And you build layers on top of that. Now, default these days, most people start with a pre-built Docker image as their base layer, something like CentOS has a Docker base layer, or Ubuntu has a Docker base layer that you can start with, or some manufacturers and providers are building these really thin shims, like I think Ubuntu calls theirs Juju, which is supposed to be like just enough to barely bootstrap this thing. It doesn't have all of your glibc, it doesn't have all of the other stuff that you need. It only has the absolute bare minimum for you to get started, which is usually your shell, a couple of glibc base libraries, and the minimum required to actually start installing packages inside of the container.
To kind of go with that, so you first start off at an operating system level, right? So Docker has to run on top of an operating system, right? So you've got your familiar things of Ubuntu, CentOS, stuff like that. But there's also pre-canned ones that's basically operating systems that are built for running Docker containers or running containers in general. So you've got CoreOS, Rancher OS, VMware's Photon, Project Atomic, also by Red Hat, I believe. Right. So those are four ones that come to my mind that are basically the forefront of basically being that container operating system as of today. So you would be able to run those bare metal on a server and then run your containers. And what we're going to show today is basically just running it on your laptop using a virtual machine.
Mm-hmm. Or if you're using Linux, directly on your laptop. So if you're using Linux, what you can do is if you sudo to root and type curl space get.docker.com and pipe that to sh, it's going to run this script and it will install Docker as a service on your Linux machine. It'll.
Something to do
Hmm?
That's not a good advice.
Yeah, piping things to a root shell is never a good idea on a regular basis, especially not on production machines. But this is your laptop. You guys blow those away every other week, right?
My name is Joe Azuzu. Trust me.
So this is the easy way to install Docker. There are also Ubuntu, Debian, and Red Hat repositories where you can install the packages where they're signed and verified. They tend to lag a week or two behind the latest releases from the Docker website. If you're not running Linux, probably the simplest way to get started is to go to docker.com/machine, I believe, right?
Docs machine.
Oh, docs/machine?
Yeah. So what Docker Machine is, you just go to Docker and then products in the machine. So what Docker Machine is, it's another open source project that comes from Docker that is basically your ability to provision Docker enabled hosts from the command line on your local laptop, right? To your VirtualBox environment, VMware Fusion environment if you're running locally, or to any cloud provider, EC2, even OpenStack, stuff like that, right?
So it's docker.com/docker-machine. And what they've got is they've got pre-built binaries for 32 and 64-bit Windows, 32 and 64-bit Mac OS, and 32 and 64-bit Linux. And you just download this thing on a Unix type system, make it executable, and you can run it.
Commands earlier. Bring the commands up for anybody that.
The command. Where did you send them to?
I sent them to the distro. It was on the distro email. To kind of understand also, if anybody is familiar using boot to Docker before, which is essentially a virtual machine on running Docker containers locally, Docker Machine is going to be basically taking over that role, right? So boot to Docker isn't going away, but the ability, you're not supposed to be like downloading the boot to Docker image and then running that inside of a VirtualBox or Fusion kind of thing, right? So boot to Docker is going to be the one, or sorry,
Machine.
Docker Machine is actually how you're going to be doing that. So if you are running on a Mac, these are the commands you need to run real quick.
Now, that said, hold on. Let me back up there for a second. Docker Machine for Mac and Windows assumes that you have VirtualBox installed.
Yes.
So if you do not have VirtualBox installed and you're running Mac or Windows, Docker Machine isn't going to do you any good.
So they still haven't provided support for like VMware or...
Yeah, there is.
Docker Machine does have support for a number of different plugins, including VMware, including Vagrant. They're going to be adding support for a couple of other items like Kubernetes and Mesos. But I think it's VMware, Azure, EC2, DigitalOcean.
There's a few.
There's a couple more. Various different cloud services provider. The thing I actually ran into this week getting ready for this presentation is I have 3 bare hardware Docker hosts at home. I cannot get Docker Machine to manage those even using their new generic driver, which is supposed to operate over SSH. It just hangs for like an hour. Even when I run it in debug mode, it's still just trying to run these SSH commands over and over and over. Doesn't really work yet for bare metal hosts. Kind of a pain in the butt, but you know, this is open source. This is 0.3 version.
Version 0.2.
Yeah.
Machine just sort of showed up pretty recently.
Last couple of weeks, month or so.
So if anybody that's running a Mac, run these 4 commands. Essentially, you're getting the Docker command line, and then you're getting Docker Machine command line.
Yeah.
That's what it's going to get you.
If you're running Windows, you can just change those URLs from builds Darwin x86 64 Docker latest to, I believe it's Windows x86 64 Docker latest, and then below Docker Machine Darwin, change that to Docker Machine Windows.
Look it up before you do it.
Yeah.
So can I nitpick one thing you said?
Sure.
You said don't trust the quality of it because it's open source. I think it's more that it's an early version.
That's what I'm saying.
Open source. Yeah.
It's open source and it's 0.3 version.
It is 0.3 version. That's the more important part of that.
Yeah. So the gist of Docker Machine is it tries to make it easier for you to set up Docker itself, as well as manage and orchestrate multiple instances of Docker. One of the problems with, and I'm sure Kenny's run into this before, running a swarm, a cluster of Docker containers, is you have to use SSL. It has to have a certificate authority. It has to have a CA with child-issued certificates. That's a real pain in the butt to set up manually. A real pain in the butt. Docker Machine has automated that when it works.
I'm hearing a lot of that. That when it works, Docker is great.
Well,
like we were saying, this is very early versions. This tool is only a couple months old.
To kind of give you an idea, so that there was the kind of theme at DockerCon was with Machine, Swarm, and Compose. They're all very experimental. They're not ready for production. But the theme at DockerCon was Docker for production. So the things we're going to go in today of actually running Docker containers, there's plenty of shops already out there that are running in production, right? One of the big ones here in town, GE, right? So GE's running Docker in production. right? They were actually presenters at DockerCon.
Oh, so that's what happened at Building 6.
Wow.
So, for those of you that are going to follow along hands-on on your machines, do you already have Docker installed either locally or via VM or VirtualBox? Yes, everybody who's going to follow along. You can try to catch up with us. You're more than welcome to use either Docker machine or use the instructions on the Docker website for boot to Docker or local install. But what I'm going to start with is how do you create a Docker container? So, as I've said before, I use Docker on a daily basis at work. I also use it in my open source programming. And I think I've shown you guys that I use Docker for some of the presentations I've used or demonstrated here previously. So this is my personal Docker repository of containers that I've built. I've got Postgres 9.4, I've got my church website, MythTV, InfluxDB, some of my CodePalooza demonstrations, things like that. So let's start off looking at Postgres 9.4 as a simple example. And you'll see in this directory is just a single file. And the Docker file is the beginning of pretty much all Docker containers. And what a Docker file is, it's basically a set of instructions for how to build your little operating system snippet, your operating system slice. And as I was saying earlier, you start off from some sort of base image. And that's that first line, from Ubuntu Utopic. So I'm starting with Ubuntu's Utopic base image, which is a very slimmed down, thin version of the, what is it, 1404, I think. And the first thing I do is I run some commands inside of there. We do an apt-get update to make sure our app database is up to date, and then we install some packages, and then we add a new Debian repository to the sources list. We update the apt-key database. We do an apt-get update again, and we install the Postgres package, and then we tell it to start. That's pretty much as simple as you can get. That would actually start up, actually that's not quite right. It's more along the lines of, instead of run on that last one, it should be a command. So this will build a Docker container with Postgres installed. We can actually say Docker build, we'll give it a name, mypgsql.
Don't run this. It's not going to work locally.
Why wouldn't this work locally?
Well, unless you get to Docker run to be able to pull it from the Docker hub. Okay. You're running it locally because you have the.
Yeah, it'll pull the base image by default.
Okay.
If you don't have the base image, it'll pull the base image during a build.
Okay.
So it could be slow.
It could be quite slow, depending on the size of the base image. Oh, sorry, Ken.
Question.
Yes.
Can you tell me again what Utopic is?
It's a version of Ubuntu. It's the codename version for 14.04.
Oh, okay. So it's just your current.
Well, actually, my laptop is running 15.04.
So Docker containers are started from some sort of a core set of tools.
Where is that core set of tools?
It's they maintain what they call the Docker Hub registry.
Sure.
Sure.
So think of Docker Hub as sort of like npm for Node or something that's.
It's like a package manager for Docker containers.
Right. So you have all these things that just sit out here, right? So you can run Nginx or Redis or MongoDB or anything. All these applications are already just prepackaged for you, right? And we'll kind of talk about that.
Mm-hmm.
So what happens is if you try to start building a container from a base image, like this one is building from Ubuntu Utopic, if I don't have that base image on my machine, by default, it's going to go out to the Docker Hub registry, it's going to download that base image. And normally when you see it download a base image, it does it in layers. It's gathering multiple files because they start from one layer and build on top of each other to multiple layers.
what kind of hardware, like you're running on a Mac or Windows, do you need a lot of RAM? Do you need CPU?
It depends on what you're going to run and why you're going to run it. I mean, you can run Docker with almost no resources.
The layer of Docker stuff is pretty minimal.
Yeah.
It's than whatever you're running inside.
Right. So you just want as many resources as the application you're trying to run inside the container. So if you're running a large database, yeah, you're going to want lots of RAM, fast I/O. If you're just running a simple Hello World Sinatra web app, you don't care. It can be tiny.
You need Ruby, you need Sinatra.
And you can install that via the Docker file. So you'll notice that each of those steps that was listed in my Docker file shows up here as like step 0, step 1, and you'll see each command that it runs from that Docker file is a new step. Each of those steps is a new layer in Docker, in the Docker container image. As I was saying earlier, those containers are built layer upon layer upon layer upon layer.
Question?
Yes.
So we're doing an apt-get update, and this is updating not our operating system, but
just inside the container. Yes.
Yeah, within the container.
Just within that one container.
Correct.
This is being built. This is a one-time thing, right?
Yeah. Well, you rebuild it whenever you make a change. So you can build this container once and reuse it hundreds of times, and have hundreds of instances if you wanted of the same container. So it's installing some packages. It'll continue going through all those steps that were listed in that Docker file until it completes successfully, and then we could actually run that container. Question?
Yeah, so that last line where you have the NDU start, that's not run right now, right? That's going to be run
No.
when you launch it? And that's the difference between
So,
run and command?
well, there's a number of different things you can do inside of a Docker file, and if you look up Docker file reference on the Docker website, you can just search in Google for Docker file reference, and it'll tell you all the possible things that you can put into a Docker file. Over here on the right-hand side, I don't know if you can see that very well, but let me scroll over a little. Oops. So these are the basics of what you can put in a Docker file. From, you can give it a maintainer name and email address. Run, command, label, expose, environment, add, copy, entry point, volume, user, workdir, and on build. So from allows you to start from a base image. You do not have to start from a base image, but it's kind of difficult to bootstrap Docker by hand. You have to use these copy commands to copy in the basics that you need to build your environment. Maintainer, only really need to put that there for your own purposes or if you're going to publish it to the public registry. Run are commands that are run during the build of the Docker container. Commands are commands that you're exposing.
One other question.
Yes.
Is there one environment that Docker runs better on versus the operating system, host operating system?
The question was, is there a Linux host OS that's a better Docker host than others? Not really. We've run Docker on Ubuntu, CentOS, RHEL, RHEL 5, 6, and 7 in our production environments.
I know there are kernel version requirements. Is there a benefit to certain kernels?
Obviously, the newer the kernel, the better I/O experience you're going to have. But most distributions, I don't think there is a distribution yet that's shipping 4.1, is it? I don't think there is. So whatever your distribution provides, if it's a kernel later than 2.6.24, you can use Docker, because that's where C groups were introduced.
So I'm noticing the documentation for command that you really can only have one. You can have multiple when the last one's executed. So does that mean that it's more practice to kind of make Docker images very small, one application?
So the point of the whole Docker ecosystem, right? This is done the microservices thing, right? So a Docker container performs one function, right? That's it. That's the kind of way that you need to be looking at these things, right? A lot of us, we build like, big Ruby on Rails applications that have like all these different things, right? And that's like not the way to run Docker containers, right? So you're going to have a container that runs your database that has a persistent
handle our Google OAuth authentication for us. So what we do is we install Supervisor D inside the container, which is kind of like a lightweight init and allows us to just run one Supervisor D command, and it starts up the services that are required to make that container functional. And so in the case of our containers at work, it'll start up Nginx, the authentication proxy, the microservice, whatever that microservice is, and it may start up a couple of ancillary tasks. We've got a cron job in there to clean out certain things in some of the applications. We've got, what else have we got in there?
Yeah, there are purists, Docker purists, who would say that that's bad and you should get it down to one command.
Sure. That's the great thing about open source is nobody's right, everybody can do it their own way. And if you disagree with me about putting multiple things inside of a single container, that's fine. Our purpose in deploying that way is to simplify deployment so that we can very simply say, we tag this release, our build server will build a Docker container out of it, and because we've had so many problems with running an internal Docker registry, we have another server that turns that into an RPM, puts it out on our Yum server, and then installs it, and then Puppet starts up the Docker container. It pains me to no end, but that's how we do it, because running your own private Docker Hub registry is still very, very unreliable. Question.
How well does this grow? I mean, so you said you put a database on one Docker container. If it grows too large for the hardware that it's on, can it just spill over onto another piece of hardware, or do you actually have to move that container from that piece of hardware to another one?
That's a good question. So the question is if you have a Docker container that exceeds the resources of single host, can you make it span multiple hosts? The answer is no. Docker doesn't do that yet. There's a good possibility that what you'll probably be able to do in the future with Swarm is that you'll be able to create clusters of database hosts and scale horizontally with Docker. But the typical use case right now is if you outgrow your hardware, you either move to bigger hardware or upgrade your hardware. Question?
Yeah, similar concept, and I guess just spinning up a new EC2 host or,
Absolutely. Absolutely. Comment?
I was just
Question?
gonna say, that will be exciting if they can come up with some way to mount a volume across multiple resources. And just
Well, that's going to be external to Docker always. It's either going to be an iSCSI mount or some kind of fiber channel storage array or NFS or Gluster or something like that.
We built a volume driver already.
Yeah.
That we're kind of pushing right now.
A Docker volume mounter.
Yeah.
Like that.
So another thing to kind of talk about so Docker containers by nature are ephemeral, right? That's kind of the way that the CPU and memory and all this other kind of stuff is that you can build a container and then it lives for whatever and then it just dies, right? they didn't really build this with the idea of data persistence, right? So the whole thought of like putting your database inside of a Docker container at first like isn't like the smartest thing, because once the container exits, then like poof, there goes your data, right? Like not the way to do it. With the latest release of Docker 1.7, they've implemented volume drivers. So we've been coding on our own end, actually making things that actually connect to persistent data stores that live on EC2 or on our own storage products as well. So that's the way that we're kind of moving towards persistent data in this kind of ephemeral world.
And we actually go a slightly simpler route. You'll see down here in this Docker file reference, there's a volume option. What you can do is you can expose a directory inside the container to be mounted to a directory outside of the container. So if you want your database to store outside of the container, you put it in this directory and you mount it as a volume inside the container.
I think we're getting a little too in the weeds, though.
Yeah.
Let's show them just some Docker PSs and BusyBox runs and stuff like that, so they can kind of see like building multiple containers and how you kind of see that you're interacting with the file system that you're.
So we've built my container now. I can actually now go Docker run, if I can spell, run -it and my PG-SQL. And for instance, the last term there, you'll see my command up here was Docker run and a couple of different options. I and T means interactive and allocate a terminal, a TTY. We're going to run the container named myPGSQL, and this is the command we're going to execute inside that container. Now, if I didn't specify a command at the end of that command line, it's going to default to whatever I defined with that CMD option inside the Docker file.
And if you do specify the command, it omits the CMD option.
Right, it overrides the CMD option. Now, if you don't want people to be able to override that CMD option, you can use entry point instead, and that's much more difficult to get around. That means the container can only be started using that entry point command. So basically what we've got is two processes, bash and my PS command that I just ran. But if we look, etc PostgreSQL, hey, it's installed. But something to take note of when you start with these basic Docker containers, you don't have tools like netstat. Oh, actually, Ubuntu base image does have it. CentOS and RHEL do not. You don't have well, you do have ifconfig. My goodness, the Ubuntu base container must be huge. wget maybe. Yep. Curl. Curl's not installed.
Well, that's weird.
And if we do a DF on this, we're only seeing the size of the container itself. Oh no, actually, we're seeing the local file system of my laptop down here.
Where'd you break?
So my laptop has.
You see it because it can take any available space on your underlying host system.
Right.
No, I didn't follow it. No, I thought it was isolated.
It is isolated,
but the storage is not. So essentially, within inside that container, any kind of storage that the container can see that's on the host system, it can consume as much as it wants, right? Unless you put it.
So within the container, you could just start writing ones and zeros, and you could eventually fill up your hard drive on the host system. But it's still isolated.
But weren't you just looking at the directory of the
No, he wasn't looking at the directory. He was looking at the.
No, I looked at DF. Yeah, disk free. Right. I cannot access the underlying host system's files unless I expose them via a mounted volume.
Is that usually just for data storage, or do people also use it for like maybe there's a bunch of shared objects?
Absolutely, you use it a bunch of different ways. We use it to bring in our configuration. We use it to store our database output. We use it for our log output. So there's a number of different reasons we use our mounted volumes. We usually only mount a single volume and then create soft links inside of there to whatever we need. So like if we need var log under that data volume, as we call it, we would create, in our case, we have an out and an in directory So things coming in get replicated into the container, things going out don't. And so we would have data out, var log, whatever. Because we have a startup script that starts all of our containers, and it copies in configurations, sets up the environment, checks permissions, things like that before the container starts up. So that actually brings up a good point. Permissions inside the container are a completely different namespace than permissions outside the container. So if I create a user inside of a container and change the ownership of a file, from outside the container, say it's on a mounted volume, that user may or may not exist. It'll just show a user ID of root, and sometimes, if the operating system's configured properly, it'll show parentheses Docker. So it's owned by root, but it's namespaced by Docker to be owned by a user inside of a container.
The users themselves are defined within the container.
Mm-hmm. And they have separate GIDs, separate UIDs, separate process IDs, everything. They're segmented from the main host completely. So what Kendrick was talking about a few minutes ago was, let's do a Docker pull busybox, right?
Do a -TID.
Just Docker run TID?
Docker run -TID.
Is D.
Detached.
Oh, detached.
So, there we go. So basically the container ran and that was it, right? So if you do a Docker PS now, you'll see that there's no container running.
Well, my Postgres container. No, it's not.
No, the container.
Oh, it's detached. So it's running in detached mode.
The Postgres container ran.
So since he exited out of the Postgres container, that container's gone.
So
right.
We were talking about this a moment ago, but we didn't get really into deep of it. The command that we were talking about in the Docker file, Docker containers start with a single command. All right? They can't run multiple commands. When that single command exits and releases its controlling terminal, the entire container shuts down. Okay? So because I started with bin bash, as soon as I exited that bash shell, the container shut down. It was done.
Okay. And so what did Docker run TID busybox do?
So this is running another container, right? This is a busybox is a very, very small, low, lightweight. As you can see, instead of doing all the Ubuntu builds, like it's just like super, super quick, right? So as you can see, what it does is it's pulling it directly from the Docker Hub.
And you'll see here these hash codes. These are the 3 different layers that make up that busybox container.
So if you're running this locally, you can go ahead and run this. So do Docker run -TID busybox, right? And you'll see it start coming down. And then from there, you're going to see this line of characters, right? This is just the unique identifier for that particular container running on your local system. Next, we did a Docker PS. This is saying, show me all the running containers I have running on my system, right? If you did a Docker PS-A, go ahead and run that. You'll see all the containers that he has ran over time, and that they've all
that I haven't deleted yet,
and whatever, right?
So every time you start up a container, it creates a, what do they call it, an image that is that separate runtime's environment. So if you want to maintain state from run to run to run, you have to grab that image ID, that container ID from Docker PS, and run it sequentially. Because every time you run it again, it's going to generate a new container ID, and a new container ID, a new container. That's really kind of the wrong way to do it, but you can do it.
So you can pick right back up where the mypgsql exited when you exited it.
I certainly could, yes.
Yeah, you can just do it. You can. So there's a few different ways you can see by identifying these things. So first is you have the unique IDs on the left-hand side, and then you also have on the right-hand side, or actually in the middle, you have these names, right? Kick-ass pasture, stoic, leaky, stoic hawking. They take adjectives and tie them to inventors of different things, right? So they're just random things of what they call these containers. You can just specify your own names when you're actually creating your container as well. So if you, as before, he made my Postgres, right? So he can create his own name if he wants to do that as well. If he wants to start it back up, all he has to do is say Docker start this container, and it restarts it back up.
It retains the state?
It can. It can, yes. It retains the state.
So back to Kenny's command that he had us run earlier, Docker run TID. You can specify a extra flag in there, --rm, that says once this container exits, remove the state.
Okay, and by the state, that would just be the state of the file system?
Mm-hmm.
Yeah,
Okay.
so like if
Inside
you,
the container.
Yeah.
if you
Inside
had
that
a
single
user
container.
Inside the container, like to use their former example, it would still be there unless you remove that layer.
Mm-hmm.
So you can store some data in the file system within that container?
Technically, yes. I'm going to tell you, don't do it.
Well, I mean, like, you would store it.
Don't do it. Do not store information inside your containers. Containers are meant to be ephemeral.
And it's hard to get to it. It really is.
If you need to store persistent data that exists beyond the life of the container, store it on a mounted volume or access it over the network.
But it doesn't say it makes any sense to have a way to reactivate the image if you don't want to.
It's there for debugging purposes.
Well, so in production, I mean, I would assume a container stays
running for long times. Yeah.
So you're saying even in that case, you don't store stuff in the local file system?
Anything that you care about, you don't want to store inside the container.
Nope.
You want to store it on a mounted volume.
Because let's say the application crashes. If the application crashes, your container is going to exit.
So are you saying the database should be exterior, but you might have your
Yes.
database engine running in the container?
Absolutely.
Okay.
Absolutely.
A mounted volume. Can you mount the volume within the container then?
Yeah.
No. So in that Docker file that we were just looking at,
I think what he's trying to find is a real-world scenario to use this. I'm thinking like you are, the database is running in this,
Well,
and
this
you're.
is a database. Let's just mount a volume.
so we would say that we want to mount a volume at /data inside the container. So if I rebuild that container, you'll notice also that this doesn't take as long.
Where are you mounting it though? You just mount it /data? Or where's that
Well,
go?
He has imported.
We'll get there. We'll get there. You'll notice that it's using cached versions of these steps. So step 0, it's using cache. So it's only rebuilding the parts that I changed in the Docker file. It doesn't rebuild the entire Docker file unless you tell it no cache equals true. So it added this volume statement to my Docker file. So now when I run that Docker container, I can say docker run -it my PG SQL. I can spell. And I can add some extra flags in here like V, and let's call it temp PG SQL data. So that's going to mount temp PG SQL from my host to data inside the container.
Do you need the volume flag inside the Docker file to be able to do this?
I believe you're supposed to have it. I don't know if it's an absolute requirement.
You can run this directly from here, or you can basically have this. You can have this command inside the Docker file.
It's probably a good idea to put it there so that your users of your container realize that you're intending for them to mount a volume.
Yeah.
So now if I run that container, tell it bin bash. Oh, actually, I've got to make that directory. And it exists. So touch temp PG SQL from outside container. So I touch that file. So now if I run that container again and ls/data, you'll see that file exists in that mounted volume. So I can create stuff from outside the container into that mounted volume, and it shows up inside the container.
And vice versa.
Yes. Now, the funny thing about this is ls-l/data, you'll see that that file is owned by root. Let's say I do add user Phillips, blah, blah, chown dphillips.dphillips data from outside container. Now, if I exit out of that container, it's dtemp because the user IDs inside the container map differently than the user IDs outside of the container.
I didn't see you mount any.
During the Docker run command, that V flag, here, see this command here, this Docker run command? This V flag is mounting the temp pgsql directory from my host OS as /data inside of the container.
Source before the colon, target after the colon.
Okay.
Like assembly.
So within containers, do you have access to device drivers and hosts?
Yes.
By default, no.
Like you want to do like X11 and stuff like that?
Well, no, I want to have my own, I/O.
Or like have something access.
If you wanted to access like a block device. So, so there's two things. Oh, go ahead.
I'm saying there's a blog out there by Jessie Frazzle. She works for Docker. She has a bunch of container hacks. And speaking of DockerCon, all the talks are now on YouTube, so you can actually go and watch all the talks that are there. But hers was basically running like
she's a little paranoid.
Doom from this past week, yeah. Doom like inside a container, right? And basically containerizing all her applications on her desktop, like Skype and stuff like that.
During her session, she basically said she does not run any applications on her host except for X and her window manager. So Chrome inside of a container, Firefox inside of a container, Tor inside of a container, games, everything is inside of a container.
That's a little. It's really not what it's meant to do, right? It's not really what it's there for.
My next thought is like, we're going to go to embedded systems. Like, can I run this on my Raspberry Pi?
Yes.
Yes.
You can run Docker on your Raspberry Pi.
So, does it have something to do with Internet of Things? Or we're getting down to the...
You can use it to do certain things that will make Internet of Things easier. It is not specifically tied to Internet of Things.
Right.
Mm-hmm. Internet of Things is an application. Docker is a tool.
Sure.
In the something I'm not clear on is, does the container actually share the same file system as the host, so to speak?
Well, it depends on if you're talking about LXC or Docker.
Well, let's talk Docker.
So in Docker, Docker creates a virtual file system that's, by default, it uses something called AUFS or AURFS, which is this layering file system that builds layer, 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 layer. It can also use ButterFS. It can also use logical volumes. But it's not the same as the host file system. It uses the host block device to store all of its data. But like, you can't access the files on the host from inside the container.
Basically, that Linux kernel is your lowest common denominator, right? That's what everything shares. And then you have all these different layers, right? So we said from Ubuntu, from CentOS, from wherever. So essentially, it builds that operating system inside the container, right?
So,
but it shares that same Linux kernel, but it has each one of those whatever unique things to it.
So, if in my development, my IDE, do I need to install that inside the Docker container?
No. So what are you programming in?
Java, Ruby, whatever.
Okay, so you go to the Docker Hub and you say Java or Ruby or whatever, and then I guarantee you there's going to be a container out there, and then you say, this is my base layer.
I'm going to stop you right there. The latest version of Eclipse has Docker built in as a first-class citizen. You can actually Maven deploy straight to Docker from Eclipse. You just say Maven run Docker.
Java, which is
there's additionally plugins for IntelliJ for doing the same thing in both IntelliJ IDEA or in PyCharm or WebStorm. All of their IDEs can use their Docker plugin. And I believe there is forthcoming a plugin for NetBeans 9 to do the same thing.
But also look at it this way, right? Like the way you're supposed to be doing this, you're not supposed to be like, oh, okay, well, I'm going to build my application here, and then I'm going to put it on GitHub, and then I'm going to do a git pull in my Docker container, and then I'm going to build it, right? Like this should all be, as Jeff showed us earlier, all through some sort of continuous integration, some sort of continuous delivery mechanism, right? Whether you're using Travis or Jenkins or anything like that, to actually be doing those tests for you and then pushing it out to a Docker container and then and running it like that, right? So that's usually like how this is really supposed to happen, and soup to nuts, like how all these dots are really connected.
So
now that's it. Go ahead.
What is a GE? You said GE using.
I didn't.
Yeah.
What are they using it for?
Oh, like the actual application, I couldn't tell you. It's just internal development stuff.
Well,
My
but
understanding is there's about 8,000 Docker containers running their environment,
Right.
plus or minus a few.
Yeah. And to give you kind of an idea, Google, I think the last thing it said, I think Google does about 2 billion containers per hour, something like that.
Sounds right.
Basically, any
Well,
service
it goes
that
back
Google
to
uses, it's all running.
The idea that they said in the beginning that a developer, I could be sitting here on my laptop working on my application in a container, right? An application that's intended to be running on a server, right? So it's not something just a little app, right? It's something that runs usually on a server that customers connect to, whatever. I can do it, and I can get it all up right, and then I can give that container to operations and say, just run this.
Right.
Right?
How many
can
times
take
have
the container and just run it on the server, as opposed to me just giving the source code and they have to recompile it, reinstall it. Da, da, da.
Let's take a step back from what Jeff just said. How many times have you guys tried to deploy an application from one Linux distro to another and run into a problem? Missing libgdx.so.2.3.7, and you go and look and it's got 2.4.1 or something because the library versions are different. When you put it inside of a container, it packages all the required libraries in the Docker container. It packages all the required ancillary programs, like if you need bash, or if you need curl, or if you need wget to run all your scripts in your application. It all goes in the container with the exact same versions that you have in your development environment. Those get deployed to production in exactly the same way. You don't have to worry about, oh man, his Python application requires Python 3, but we've got to have Python 2.7.6 for this other application. We can't install those on the same machines, or we've got to do virtual envs, which are a pain in the butt, or we've got different Ruby libraries that are conflicting. Docker containers resolve that because they run in isolation. They use their own packaged libraries.
Instead of thinking of the word application, right? Like, oh, I wrote my application, it runs well and stuff. They want you to think in terms of the word container, right? So I develop my application in this container, and that container is inherently portable. I could take this Ubuntu container and go run it on a Red Hat system, and it'll work.
Austin, you have a question.
I think what this boils down to, at least my understanding, is Dockers are live CDs running on top of the host OS.
That's not really a good way to think about it. So Austin was asking, are they kind of like a live CD running on OS? And what it really is it's a way of slicing and dicing your OS to assign certain resources to certain applications in isolation. Because not only can you isolate the process and namespace so that you can use different libraries, different files, different versions inside the container, you can also limit the amount of memory, limit the amount of CPU utilization, and limit network I/O for each individual container separately.
It's more, it's something that you can plug in anywhere. It's going to run the same everywhere, but without mounting it externally, much like rebooting, you're going to lose everything.
To a certain extent. Yes, John. Question.
Yeah. Where is all of this stuff where is the container stored? It's not.
So by default, it stores everything in these AURFS files under varlib, unless you tell it
Don't worry about it. It's just magic.
Well, that's what.
Don't even worry about it.
It's just files on the file system.
The fear of Docker, at least for me, is the magic behind it, because there are a lot of, we keep on talking about the size of, like, the scope of Docker has grown significantly, well beyond. I mean, we're talking about a distributed file system that has layering, UFS. We have new network protocols. You're talking about installing system D inside a container. I mean,
Time out. Let's back up one step. It's not a distributed file system.
Layering file system.
It's a layering file system. My apologies. Yeah, sure. It's a layering file system in which you're pulling over the network. I mean, so there is a lot of magic going on.
Again, you don't have to pull it over the network. You can start from scratch on Docker containers and build it however you want with only the things you want.
If you want to make your life hard.
Well,
Well, no, I think he's got a good point. There's a lot of magic going on. You can pick any particular area where there's magic. Like, look at that. I can't tell you what that is. Right?
But if you stop and think
Hold on,
about it,
hold on. So the point is that Docker allows you to go many different levels, right? You can operate up at the magic level and not give a damn about how it works. But you can actually peek under layer if you want to. If you need to be the ops guy who's like, you know what? I got to understand when this goes down, how do I fix it? You can actually peek under the covers and get down to that and that. And I don't think they're trying to cover that tonight. So they're staying up at the magic.
You got to understand, this is a huge topic. There's no way we can cover it all in one meeting, even if Jeff hadn't taken 45 minutes of my valuable time.
Oh, man, I was on the agenda. It was only 30.
So anyway, back to what you're saying about magic. apt-get, yum, those are magic too.
Can we see how
They're just as magic as what you're saying about these container layers. The nice thing is if you actually pull a Docker image, for example, if I do Docker pull Ubuntu and Vivid, for example. So I pull an Ubuntu layer. When that actually pulls down, a lot of these vendors have what they call verified base images, and Docker will tell you that this is a verified base image. We know for sure this is signed, GPG, checksummed, and you've got exactly what you're supposed to have, so you don't have to worry about people injecting things into your base layers.
If you couldn't give me about GE, what does your company do with Docker introduction?
I was just explaining that to him a few minutes ago. We build microservices into Docker containers, and we deploy them in dev, staging, and production.
Basically, every application they do is in a container.
Web server, database, whatever.
If you want to know specifically what that application does, I cannot talk about that. It's a bunch of RESTful services and a web UI and a database and a couple of other things.
Remember, this is an infrastructure tool, right? It's not like we're not talking like programming languages, right? It's an infrastructure tool that's how you basically make the applications run.
Right.
Okay.
But it's
Jamie.
Okay.
When a developer ships their container to an ops team, they're not shipping a container, they're just shipping Docker file. Right?
They certainly can ship the container. You could do it either way, depending on how you do things. So, for example, if you're using like Node to design applications, if you're pushing all your stuff up to your own private NPM repository, and your Docker file is set up to pull all the artifacts from that NPM repository, then just send them the Docker file. If they're not set up to pull all of that stuff from some sort of artifact repository, you can actually send them the Docker container. And more so, you can use Docker Squash, which will squash those layers all into one layer and save you some space.
Put it this way. So your best way to be able to do this is to create the Docker file. Why? Right. So say you create a Docker container and you hand it over to operations, and you're like, here we go. Here's application 1.0 ready. Here you go. And then 1.1's ready to go. And then you got to go back and you got to rebuild your container. You got to give it to them and say, oh, here's 1.1. Instead of just basically saying, like, in my Docker file, pull from GitHub, release 1.1, and then basically they just, every time they rerun the Docker file, it's just going to go ahead and just update and pull the latest.
But here's the question that I have about that is getting back to the library version numbers. At the top of most Docker files, it's apt-get update or whatever, right?
Mm-hmm.
To update your dependencies. You could potentially run into a situation where between 1.0 and 1.1, some weird library somewhere got a version number bump.
If you run into that problem,
that's why you get test staging.
There we go.
Yep. If you run into that problem, then you hard code that version in your Docker file.
Yeah.
All right.
So
Question.
two things. So one, to me, it's still sounding like, understand where I'm coming from, right? I'm trying to make an assessment as to whether or not we should spend resources on doing anything with production or with Docker in production, right?
Mm-hmm.
As well as I'm interested in Docker anyway. So what I'm hearing is that all the same old sysadmin issues of version numbers and how do we get this stuff? How do we check it? Because as I read that line right there, it says is a tech preview and should not be relied on to provide security, right? So I mean, there's a lot of these same old sysadmin things we still need to worry about, and that Docker, in some ways, what I'm hearing, just another layer of complexity on top of all those old systems?
No. So actually, let me get on this because we use this every day in production, and I'm going to somewhat agree with you. Docker does add layers of complexity because by company policy, we're required to use Red Hat Enterprise Linux on VMware. So we've got VMware ESX, Red Hat Enterprise Linux, Docker, containers, which is kind of a pain in the butt. On top of that, we're required to run a particular SE Linux profile on our Red Hat Enterprise Linux. And by default, it breaks Docker like crazy. SE Linux is a royal pain in the butt when it comes to Docker. So then on top of that, you have to worry about when Docker starts up, it has particular ulimits set, it has particular kernel parameters set, and those are limiting the containers that run inside of Docker as well. So is there extra coordination with Docker? Yes, there is. Is it tremendous overhead? Not once you get used to it. Once you get used to it, it actually eases a lot of things that you do on a regular basis. It's just a matter of getting over those growing pains that most of us are still dealing with on a daily basis.
And can I also just ask, I mean, do you use Puppet or Chef or any of those tools?
Yeah.
Those tools suck. Ansible's better, but those tools are horrible. And those tools are intended to set up your infrastructure in a programmatic type way. This is another tool that I consider a better solution to the same set of problems. So I'm looking at this and to replace our crappy Puppet infrastructure, right? Because you have much more reliable versions of things, and it seems to be a lot faster and simpler to work with from my experimentation.
When you get to the swarm and the machine portion of it, and really start digging into it, and they start getting more production ready, you're going to find out Chef, Puppet, and Ansible, you really don't need it anymore. It kind of starts disappearing.
I'm going to disagree with that because you're always going to have containers that need to work in different environments and need different configurations for different environments. So, for example, one of the microservices we have is a monitoring service for vSphere. It pulls all the updates out of the vSphere SOAP API every time there's something changing and feeds it back into our operations control panel where people can monitor what's going on. We have 16 data centers. We have about 400 vCenter servers. And we have one Docker container, well, actually a pair of Docker containers dedicated to each vCenter server. Each one of those has different configs. We use Puppet to distribute the appropriate config for each of those Docker containers. So you can do a lot of base configuration inside the container, but there's always going to be differences that, different data centers or different vCenter clusters or whatever are going to require some sort of external configuration. The way we're headed in our team is using environment variables, which you can specify using the Docker orchestration tools, using like Docker Compose or Kubernetes or Mesos or Consul. You can actually push environment variables to configure each container instance. That seems to be easier for us if we set up our containers to use those environment variables to set up the implementation specifics. But everybody's got different experiences. Everybody has different specialties and what's the right word? Expertises of things they've used in the past. We do really well with Puppet.
I'd be interested to hear kind of the other side of that, because you had said, yeah, I would be interested to hear your side.
So what do you use it?
So
what do you use in Ansible to set up, right? You're using it to basically set up a host, right? That's going to then own an application, right? Whether it's a physical host or a virtual machine, right? Docker, right? It's going to be running either probably usually today inside of a virtual machine. So right now, Docker machine is the way that we provision Docker-enabled hosts, right? Docker doesn't rely on anything of the underlying host to be able to run an application, right? So essentially, at that point, once Docker machine has your host up and running, and then you run Docker containers on top of it, there's nothing that you have to configure for the host machine, right? Unless we're going to be building things that actually deal with the storage side of it, but that's about it for the persistence of data. So that's the kind of way that I look at it, right? Like Docker machine provisions virtual machines, Ansible provisions virtual machines, but those virtual machines you're provisioning with Ansible are doing it in such a way that you're doing apt installations or whatever to have certain libraries that are ready to put the application on top of it. All that stuff is built inside the container, right? So Docker machine builds the host, Docker container, everything's in here. Does that make sense?
Yeah,
I can whiteboard it later if you want.
Yeah, I think, yeah.
Brandon, Barbie had a question.
I knew you were bringing up security.
Well, I'm going somewhere else. I was just thinking in terms of like patch management, that this could be a nightmare. But
no.
You know, if you think about it though, this is sort of like, you know, let's throw away kind of how we were doing things before and come up with a better way. And it's sort of like whenever you do that, it starts out very customized.
Mm-hmm.
I can see where it would become more.
You're welcome to.
It would become more.
Okay, so to kind of touch on some of the security things, I'll kind of start off at the bottom layer. So I talked about it earlier. There's these distributions that are basically made to run containers, right? KYOSS and Rancher. All these have automatic updates already built into it, right? And these are like just enough to just run containers, right? There's nothing else that these things are running, so that's starting to mitigate a lot of security because there's really nothing else to run on these operating systems, right? Now you're talking about updating the stuff that's inside the container, right? So when that needs to happen, developer X over here, he goes to his container, right? Or he goes to whatever it is. If there's a new version of Ubuntu or whatever it is, you know, you can go ahead and you can put in the new version, whatever's been approved by the security team, or you do rolling upgrades, right? You just basically have 10 containers all running the same application, right? Because this is microservice, this is a distributed application. They're all running the same thing right in front of a load balancer. Then you start doing rolling upgrades, right? So you upgrade the first 5, then kill them, kill the old 5, and then bring up the new 5, and then kill the rest of them, right? So you have this kind of rolling upgrade approach to it. That's how you kind of do some of the security aspect around the upgrade portion.
That's certainly one way to approach it. We do it a slightly different way. What we do is we have automated canary builds that happen through our continuous integration environment. So let's say Red Hat releases patches or CentOS releases patches, and we have an automated system that monitors to see when new patches are available for CentOS or Red Hat for packages that we use in any of our containers. And we actually have that documented pretty well when part of our container build audits the list of packages installed inside the containers. So if one of those packages has a patch that needs to come out, our continuous integration system rebuilds the container with all the latest versions. Then it tests it in dev and or staging and does all of our soak and smoke tests against that new container that it built with all the latest updates. If it succeeds, then it goes into a queue for manual testing and approval. That approval is in the form of a git tag. If we tag a release, our continuous deployment system builds the container that goes out to production. If we run into a problem with one of those canary builds, like we have a version incompatibility or, you know, God forbid, tomorrow's going to be hell with that OpenSSL bug that they're getting ready to announce. If something like that comes along and we need to get it out more quickly, we might manually build a container and test it, and then force operations to do like an emergency release.
And another thing, if you're worried about Docker security, like as the actual product itself, there's already been a lot of things that people brought about security holes and stuff like that to it. So for the foreseeable future, until that stuff is fixed, really you have isolation between containers if you run them on separate virtual machines, right? If that's what if you're really worried about that sort of isolation, and most likely you're a cloud provider doing that, making sure you're not running 2 consumers on the same host or the same virtual machine.
Mm-hmm. That's
on kind of dovetailing on her question. So I could
have a container that had an unpatched older product that may have a serious security hole in it, and I may be putting it out on a server somewhere to run that's all secure, but I'm introducing an opportunity to cause, I don't know, what something.
Mm-hmm. So in that instance, let's say, for example, you had an old web application that could potentially give somebody remote console access, for example. What happens is they break your container, and all you have access to is what's in the container.
Okay.
So as long as it's not a kernel vulnerability, you hope that whoever's maintaining your Docker hosts is keeping your host kernel updated and patched.
Okay.
As long as it's not a kernel vulnerability, they can't get outside of the container. All they have access to is what's in the container.
So would this be, we're talking about using this in production, but getting back to Joe's idea and the whole Internet of Things, how lightweight can this be? Could this be used, is this something roughly comparable to like JavaScript or Java applets where you could download something on the fly from somebody you don't really know?
Apples and oranges.
Yes.
No, I follow what he's
Yeah,
wanting to say.
GitHub.
He wants to isolate whatever he's getting from somebody, so in case it's got something malicious in it, it's not going to mess whatever else he's got.
Okay, so you know that Docker Hub, right? That has all those different images that are out there, right? So you can go to them, and there's a set few of them that are, you know, check signed and verified that says like, oh, this comes from Ubuntu, or this comes from Nginx, or this comes from Redis. And then there's also ones that says like, oh, this is Alan's versions of Redis, right? And then you can go and you can use that if you really wanted to, right? You have no idea what he put in there, right? That is available if you really want to do that, and there can be vulnerabilities.
And how much
but
damage can you do?
Shut up! I'll find
Whatever I
it.
want.
I haven't tried.
I can do all kinds of weird stuff in there.
But there, at DockerCon, they announced a new product they're going to be rolling out. That's essentially a way that anybody can then verify any packages that go up there. And
Yeah, so Devin has released several packages, and he shared with the list, like the InfluxDB or whatever that you get to play with, right?
Mm-hmm.
So then it's like GitHub when you check out somebody else's code. You're checking out somebody else's container.
Oh, that's just on the Grafana one.
Right? So you can pull down their container, you can spin it up and run it.
I think I've got one that's got like 7 or
Everything
8.
that's running inside that container is supposed to only run inside that container, but maybe it does web service calls to go out to the outside world. Or maybe it just writes ones and zeros and fills up your hard drive. I mean, it can do whatever it's going to do if you run it.
I mean, you use the term sandbox with JavaScript and applets, and so I guess that's what we're talking about.
What you're talking
about.
Well, I don't think there's been a complete analysis of how safe Docker containers really are. Nobody's gone in and done a very in-depth, extreme analysis of how difficult it is to break outside of a C group in Linux kernel. Now, that said, there have been extensive testings by groups like Los Alamos or JPL and NSA and various corporations have tried to break out of containers. They've found some vulnerabilities. Those vulnerabilities have gotten patched in the base Linux kernel. Those patches have caused problems in various Docker releases, which have then subsequently been patched. And what you run into is sometimes certain things won't run inside of a Docker container or inside of an LXC container because they require lower level access than what Docker allows or what containers allow. In Docker's case, when this happens, you can run in what they call privileged mode, which gives you access to kernel calls. This is not something I recommend for production. But the problem is let's say you have an application failure in production and you need to debug it. If you need to use a tool like strace, or you need to be able to run valgrind or something to look for a memory leak, all of those tools require kernel calls, which means you have to run the container in privileged mode to debug it.
Or you say, fuck it, and you kill the container and go run it somewhere else.
Well, except the problem comes back 2 days later. We've been doing that over and over.
But then you've got 2 days to go and debug it somewhere else. So.
But we can't make it reproduce in dev or staging, so
well,
there's something particular about the data in production.
Don't use Docker.
That's not what I'm hearing.
Well, no.
No,
What
no.
what we do is we temporarily enable privilege mode. We debug the problem, then we disable privilege mode. And these are all running as replicated, at least 2 instances behind a load balancer. So we shut one down, run it in privilege mode, debug it, shut it back down, take it out of privilege mode, run it again.
Getting back a little bit to device drivers, can you have a container that talks to one piece of hardware, like an Ethernet driver, Ethernet card?
Why do you need to talk to an Ethernet driver or Ethernet card?
What I'm thinking of is I'm more of the hardware sort of guy. I like to play with instruments and so forth.
He's got a Raspberry Pi.
And I want to be able to, I've got a Raspberry Pi on my Linux machine. So what I want to do is sort of have like a container that is talking to that Raspberry Pi doing its data collection. And I want it to be totally isolated. And so you have this container talk through a separate piece of a separate NIC card.
Why do you need a separate NIC card though?
Well, because
you don't really have
to. It's not really Ethernet because it's something else. Because it's it's a Wi-Fi. It's not Wi-Fi. It's basically a node on the Internet of Things, for example.
There's a few different flags that you can use, right? So I think you're thinking too hard.
Yeah, maybe I am.
Okay, so essentially,
how I could use this.
Essentially, you can have have a container use the host networking, so it basically just gets that host IP and basically just does a port forwarding into it.
And when you do that host networking, you could specify which interface to bind to as well.
Exactly. So say if you're making something on your Raspberry Pi, say a web server, and you want to expose port 80, then you say I'm going to expose port 8080, so external host, internal host, and then you just go to the IP address of that external host port 80, and it does the networking traffic back into the container.
Yeah, let me flip the question around though. I mean, why wouldn't you want to allocate specific hardware resources to specific containers, right? So some software comes with key fobs, for example, for their DRM, right? So you might want to only allocate those key fobs to specific containers.
That comes back to the Unix philosophy of everything's a file. So if it's like a character device, a USB key fob would typically mount as a character device in Linux. You just mount that as part of your mounted volumes.
Right.
And then the container can access that key fob. So specifically, if it's something in the device file system, this is how Jess was doing some of the things that she was doing with X Windows and video and audio and stuff. She mounted dev file system items inside the container using volume mounts.
I have a super dim recollection, and you guys correct me if I'm wrong, but I think you can do that with SRIOV devices as well.
What?
I don't know.
I don't know what that is.
I've heard the term in VMware world, but I haven't really heard it too much.
Single root I/O virtualization.
Yeah,
I think
I've heard of it.
I think you can map SRIOV devices into one container and not into others. But I'm not really sure that, and so why don't we just pretend I didn't say that?
/dev or whatever, then you can basically mount that.
Except NIC cards don't really work that way in Linux.
Like I said, I think you're thinking too hard.
Yeah.
But if you wanted to talk to a serial device or a parallel device or something like that, you could mount the dev file system entry inside of your container to access it. But if it's something that can only be accessed via a kernel syscall, then privileged mode is your only option. Barton. Jamie, I'll get you next.
I'm thinking about your the sort of ephemeral nature of this. What happens if you have something that needs to be cached? Say you're running memcache or something like that. You've got memory that you would like to stay persistent between runs of the whatever program you're running.
So the question is there a way with Docker to keep memory stuff persistent? There's no way to do that with a regular application.
You have to flush it.
I mean, if you restart memcached, you lose everything that was in the memory cache.
Well, yeah, but okay, so how would you use memcache in Docker? What would you mean?
Same thing, you use it in the regular world.
So you have a service running.
Yeah, memcache is accessed over the network, right?
Right.
So you expose the memcached port, and you run it inside the Docker container, and your application talks to that port that's exposed from the Docker container.
And that's sort of like one of the easy use cases to start with.
People love using the Redis Docker container that's out on the registry because it's super simple to start it up and run it. It takes like 10 seconds literally to download that container, fire it up, and make it work.
Because it doesn't need it.
It has no external dependencies, no external configuration. You just say run, expose this port, boom, and you've got Redis. And if you want to, you can say, okay, only allocate one CPU core and X amount of RAM, and it's not allowed to exceed that. Jamie.
Where is your load balancer? Not on Docker.
No.
You can if you want.
So Jamie was asking where's the load balancer running. You certainly could run like HA Linux or Heartbeat D or something like that as a load balancer inside of Docker containers. Absolutely. We actually use appliances ourselves. They're VMware appliances from Riverbed.
But I want to set host, I didn't mean in the container.
No, a lot of people will run a container as a load balancer that gives access to other containers, either running on that same system or across other systems.
Mm-hmm. So,
what if you have a load balancer span Docker?
one of the links that I posted to the mailing list earlier today about some of the documentation that I was showing off was down here. This link about scaling to infinity with Docker, Swarm, Compose, and Consul. This demonstration actually uses Consul as the load balancer, as well as the configuration registry, as well as the service discovery methodology, or service registry.
This is the clock that I need.
Yeah, I tried to go through this a couple times this week, and his Ansible playbooks fail every time when I try to use this. So I've sent him an email. He got back to me earlier today that he's gonna try and update it and fix it. He ran all of these tests apparently on Fedora, and never tested it on Debian or Ubuntu or anything like that. So expect an update. This link, if you guys want it, is on the KYOSS mailing list in the email I sent earlier, where it says tonight, open discussion and hands-on. It's like the third email down. So he talks about actual orchestration using multiple tools. There's also out on Mesosphere's website, Mesosphere, Docker, Swarm. They have Docker containers at scale on their blog, where they're talking about using Docker, Docker Compose, Docker Machine, and Docker Swarm in conjunction with Apache Mesos. And specifically, they've got a proprietary tool called Marathon, which allows you to run distributed clustering of Docker containers. So there's lots and lots of different ways to approach this problem, and it really depends on your environment, your comfort level, whether or not you want to pay for proprietary software or not, things like that.
Would this type of thing be equivalent with like Kubernetes? Is that the same class of software?
Similar,
yeah,
but
they're
Mesos
all kind of fighting that space right now.
Mesos and Consul are certainly far more featureful than Kubernetes. Kubernetes is like really bare bones. That's why they've integrated them in with like OpenStack, OpenShift. OpenStack, OpenShift provides a bunch of the functionality that Kubernetes doesn't have.
I think you're going to start seeing Kubernetes kind of fall off a little bit because the thing is, like, Docker, one thing to understand is with this infrastructure thing is Docker is building a platform, right? It's building like an entire way to run your data center using Docker tools. And if they're building native capabilities to do everything you want, then why would you go and pull something that Google built that you've got to go and just figure out?
Well, and on top of that, Kubernetes is it's basically a pile of sticks that falls down every time I try to use it. It's really, really tenuous at best in doing what you really want to do. It's limited in its functionality, and I guess the right way to answer this is we started deploying Docker at 1.3, and we have had a whole lot of growing pains. A whole lot of growing pains. This is still very young software. This is still very early versions. But I would expect if you start using the software now, even in production, I would say by the middle of next year, you're going to have something that's enterprise grade, manageable, orchestrable. This is going that fast. The development, the excitement is so huge. The mind share is massive.
So if I could give you one takeaway for tonight, I would say you don't have to convert your entire data center to Docker, right? If you want to just screw around with this stuff, pick one app. Pick one small, unimportant app and put it in a container, right? And try doing some container-like things with it.
I would go even further back than that. With the new versions of Docker Machine, just install VirtualBox. Tell Docker Machine to spin up a couple of small VMs on your local laptop and play with it that way. Pull down some containers that are already pre-built on the registry and plug them together.
See how it works. Maybe this is not the thing for you, right? Maybe it doesn't make sense for your apps, but go try it, right? There's a lot of believers in this room, and I'm kind of a believer too. I don't use them heavily in what I need to do because I'm not an ops kind of guy, but it's genuinely useful stuff, and it is worth playing with to understand, to see if it is applicable to you and your applications and your situation. So start small. Try one app, try developing on it, and then try, putting exactly what you did into production. That kind of thing. Just do one small test.
It took a decade for virtualization to really become like completely mainstream. This will take 3 years.
3 years.
3 years.
Well, that's not quite apples and apples, right? Because
no, it's not.
Virtualization kicked this off pretty
yeah,
well,
exactly. Everybody had to get comfortable with that first, and this is just the next evolution.
So it's 9 o'clock. This is our typical normal stop time. I'm perfectly willing to stay later. I don't know if Kenny or anybody else is willing to stay later, but I would like to let everybody have a chance for a bio break. And we'll come back in, say, 10 minutes if you guys want to continue. Or, Kaysen, are you up for staying later? Or thank you, Kaysen.
One more thing. If you kind of want to get plugged into some of the things that are happening, Eric Lathrop built a new site called Louisville.io. There's a Slack channel on there. We all kind of just talk on Slack all day.
Sweet. So, I love Slack. Slack
is
awesome.
Us on Slack, Louisville.io.
And going back to what Jeff said earlier about his GitHub integrations, we use Bitbucket, but they have a similar capability. Every time we get a pull request or a merge or whatever in Bitbucket, it posts to a special Slack channel where we can actually see the updates. It's really nice. Slack has really nice webhook integrations. Pretty cool. So, is anybody interested in continuing? Show of hands. Okay, come back here 10 minutes, and I don't know if Kenny's willing to stay or not. Okay, so at least Kenny and I will stick around and try and answer questions or feed you guys more from the fire hose.
So you were asking about the networking part of it.
Just trying to figure out.
So like right here, so we can say, basically just a dash link.
Hey, Kaysen, if we go outside, we're going to get locked out, right?
So it says
I will.
Yeah. Okay, dash link and everything. Right, so when I was doing, so right here, if I really wanted to, I wanted to link these two containers so they could talk to one another. When I ran this, I would say Docker run using box link, and then I'll say right.
That's usually not what you tell me. You were a teacher. You'd be my favorite class.
So you can't really see, but actually talk to me. The networking is very fast. You're not really going to be able to talk to one another because I'm exposed to candidates of myself. So if I expose to 80 or 3 or API points or something like that, the other thing is, so you need a Raspberry Pi, right? If you think about it, Raspberry Pi, you might all without ever turning it off or reformatting it or whatever.
There's a lot of applications out there. Companies want to data. They don't want to put it into, they don't want to put the container for the collection of this way, you wouldn't necessarily have to have it separate.
Are you calling logs or are you just clicking this? Yeah, okay, so I mean, essentially what you do is right, so if you're collecting that data, what you need to collect that data. Okay, so you just need to basically count the volume and the site. Right, that or you can say like I've got an NFS count somewhere on some server or somewhere like an array. I mount that to the actual link post, and then I mount that to the container, right? So essentially, it's just like a big pipe. Yeah. Right. Yeah, this is all just kind of infrastructure. Right.
And there are all these things that will
right. Well, that's what a lot of these, like I said, those lightweight, it's basically container-only kind of file or operating systems. Like that's what they're to get rid of the loads. That's the way the
routing layer. Does the microservices after you build it, just Now, I talked to them about the guy That's what it costs.
I'm just looking at them like 6 years ago. Yes, we're 3 cop cars outside the audience. Yes. The other
All right, folks, we've just been told by the cleaning crew that we have until 9:30, so we can answer a couple more questions if you guys are ready.
Yeah, some people started writing emails and they started like,
Okay, it's now 10 minutes after 9. Hey, guys, we have a limited amount of time. You're more than welcome to continue your conversations outside after we're kicked out here in 20 minutes. But to make sure that we have time to answer everybody's questions, let's go ahead and get back to it. Thank you guys for sticking around.
I've got a question about management tools, just capabilities.
So
You can move a live container from one host to the other. Are these management tools able to spin up new containers for me to load?
So there's a number of management tools around the Docker infrastructure, Docker ecosystem nowadays that can do a lot of those functionalities. Docker Swarm, for example, has the capability to do their scale command, that you can spin up some containers on your Docker cluster using Docker Swarm, and you can say, scale it to X number of instances of that container. Oh, Docker Compose, sorry.
Yeah, go to that mind map, and it'll show you all the different kind of products. Are you talking like UI-based sort of stuff, or are you talking about just
trying to learn what's just not state of the art, but state of
right? So
pretty good. Right.
So the whole like motion of containers from one host to another is still it's not seamless, right? There is a break in communication at some point. That's what the company that developed Flocker, like Cluster HQ, they're the ones that kind of made that. So expect to see that get better. From managing it from an outside perspective, like it just happens. I don't know, like whatever, right? You just have to basically just do a Docker PS on your Swarm cluster and then watch it. And when it goes, it's now the other host, right? That's just kind of how it works.
Part of the integration that's soon to be forthcoming, they're working on integration modules for Docker Swarm to be able to use things like Apache Mesos or Zookeeper and things like that to automatically manage clusters and automatically scale them based on load. And that's, right now, the way that's done in Mesos is you write your own scheduler code. Mesosphere, the the commercial entity that's creating extensions to Apache Mesos has a tool they call Marathon that has that built for you, but it is a commercial tool. Kubernetes has some functionality, especially when it's integrated with OpenStack, OpenShift, to automatically scale applications inside of Docker containers. And then there's other tools that exist in the ecosystem that are in various states of maturity. I was just telling Kaysen outside when we were talking that I would expect this time next year you're probably going to see somebody, or at least one somebody, if not 3 or 4 somebodies, will have come out with a nice point-and-click web app for managing Docker clusters.
There's ship or it's not called shipper. What's it called? There's a few UI-based Docker things already, but they're okay.
But yeah, there's like run your own platform as a service on Docker systems, Deis, and then there's the other one, Flynn. Deis and Flynn were the two I've been watching. Right.
Mm-hmm. So would I say it's would I say that it's mature? No, there are things available for doing that though.
How would Microsoft implement this? Would they create like a system environment that would emulate the Docker?
Well, they have POSIX conformance on Windows, and they've had that for a while. I would imagine that they've had to grow a bunch of Linux-like features to support it. And if they're only going to do it in Azure, it's not something you can buy in Windows 10 for your home laptop. That might very well be a viable business case for them. It's a new Microsoft these days, right? So this is not unimaginable.
Yeah, they're laying off like they've never laid off before.
They're implementing SSH. Come on.
Yeah.
This is Microsoft. This is Microsoft.
Brave new world.
As much as we open source people don't like Microsoft, they're still killing it pretty heavily in the enterprise space, and they are making a lot of people happy by some of the new directions that they're going. So,
I don't know how possible it would be to implement something like C groups and Docker inside of Windows. Jeff's right. There has for many years been a POSIX compatibility toolkit that you can apply on top of Windows. Since about NT4, there's been a POSIX compatibility layer that works kind of like Cygwin, but a little bit more integrated with Windows. I wouldn't say better because the tool set inside of the POSIX toolkit for Windows is very limited. But it does expose all of the right APIs to run POSIX applications.
Well, it sounds like this is going to be as big as you guys are saying.
They need to cash in on
Microsoft
it.
has to do it. You know?
Yeah.
They really well, and they've already made the first steps by allowing you to run Linux virtual machines and Docker containers inside of Azure.
I guess
all this being said, an announcement is one thing, right? When they have a shipping product, then I think we'll all have a look at it and see if it's any good, right? That's going to be the real proof in the pudding. It's very interesting at this point to talk about, but let's see what happens and what they actually end up shipping. I'm sure that's still a ways off.
It kind of went up saying that most anything you're running inside of a Docker container or native Linux applications, like you're not going to be running something that requires Visual Basic inside of a container today.
Well, maybe that's not their vision. Yeah.
Today. So, like I said, that kind of went without saying. What was understood.
Yep.
So, right now it's looking more like Windows Docker stuff is going to be POSIX.
We can't answer any questions about Windows Docker.
Yeah, it's all speculation.
We have no idea what Microsoft's trying to do there. Can't really say. Yes.
So when you spin up a new container, if it's all right if I change the subject.
Yes. Sure.
Please do.
So when you spin up a new container and you get a hash for the actual container instance, and you can see that hash to exist, and theoretically, I'm not saying it's a good idea, that's not really the point of the question, you can theoretically start that container up again.
Yep.
Is it using AUFS underneath all that so that you don't have 40 copies of SBIN
So,
and all of your C requirements to make a Linux system actually runs?
So it's using whatever your underlying file system driver is. By default, that's AURFS, but depending on how you've configured it, it can use ButterFS or Linux logical volumes. But it is doing layers. So every time you start up that subsequent container that you've built on top of, it's creating a new layer.
Sorry, let me rephrase because I'm not quite sure that answers it. So you have two identical containers that you just started up right next to one another, right? Are they, is just the top layer of that file system different, or is there, because really,
Do they share?
yeah, how low are they sharing between containers?
So if you, actually, I don't know about the layer. All I know is when you basically run a container, and then it's going to pull it from Docker Hub or where it's going to pull it from. And then you run it again, it's just going to use that same exact image.
I think he's asking a different question. So let's say you create a container from the same base image. Let's say
If the container is 600 meg, we'll say just pretend for a moment, am I going to have two 600 meg file systems, or am I going to have one 500 and two 100?
That's not true. That's not true.
For every layer building up until that last run command, it will be the same cached version of that. So every layer building up to that. So most of your 600 meg is broken into all of these pre-existing layers, right? Okay. Your run command, let's say that triggers 10 meg of data, right? If somehow or another that run command triggers 10 meg of data, you'll have 10 meg and 10 meg. They will not be the same.
So I will have,
we're talking about identical containers?
So the layers that are built up when you build the Docker container from the Docker file, you saw we started with that base image like CentOS or Ubuntu or whatever, and we built with our run commands new layers doing different things like apt-get or apt-update and things like that, installing applications, whatever. When you start up, say, 5 instances of that container, all of those layers are shared among those 5 instances. The top layer for each individual instance is not shared. So that's only the differences inside each instance of that container.
So
when you shut down that container,
and then two 10 meg AUFS, whatever. The point is, I'll have 620 meg taken up opposed to 1200 meg.
Correct.
We're talking file system here, right?
Correct.
Other resources is a different story, right?
Right,
Like
we're not
RAM,
talking
different thing.
memory or anything.
Yeah.
Right.
Specifically hard drive space.
So that's why layering actually works really well for Docker containers, because so for our example, we tried to do at the beginning of our Docker experiment at work, we tried to start with a base image that had, so we started out with a CentOS base image, and then we installed just the common tools that we use in every one of our microservices. So Nginx, our authentication proxy, supervisor D, and we built those into layers that we could reuse on all the containers. And then we built the specific portions of our applications on the next layers. So everything that is common layer-wise to each of those microservices is shared.
I'm following. I'm just trying to see what my disk usage would be.
So can you compare or contrast it with, say, Solaris Zone?
Almost identical, with the exception that Docker builds this virtual layered file system, and Zones uses more like a Chroot style thing.
Yeah. But other than that, there's a lot of similarities.
Something I will say something I will say around that though is Solaris Zones is verifiably more secure.
Verifiably, yeah.
Similar, is it in some ways similar to jails as well?
Yes, BSD jails are another concept that's very similar to containers. Also, BSD jails are verifiably more secure. They've had a whole lot more eyes in depth looking at them over the years. So when you look at companies like Joyent, Joyent has been doing Solaris Zone styles containers for Node.js applications commercially for some time. And that's the product that they offer, is their Joyent OS, which is based on Solaris Zones. It's Open Indiana Solaris Zones. It's very similar, and they've made new versions of Joyent OS that work very similar to how Docker does. I think they even have a driver where you can take a Docker file and generate a Joyent OS zone from that Docker file using AURFS and everything on Solaris. The problem is C groups in Linux are relatively young, and they have not been through that exhaustive level of security, penetration testing, validation, things like that.
Have you experienced, anyone else have a question before I jump in? Have you had any experience running a Postgres system on top of this? Specifically, data storage. What's nice about Postgres is, just kind of give it the data volume, and then you're off and running. Am I accurate? And then can you spin up a whole bunch of containers on top of that one data volume? I'm trying to remember how Postgres ends up working with that.
So you got to understand that at least from if they're all running on the same file system, the same host, then yeah, because there's no kind of locking involved. When you get into iSCSI and NFS, then you're going to start getting the locking if you're running it on different hosts, right? Postgres, in most of those relational databases, you're going to give it a beefy container that's going to run most of the system processes, and then you're going to mount an outside volume, and that's how it's going to run its data.
Mm-hmm.
That's how most relational databases how they're going to.
Something else to keep in mind with something like Postgres. Postgres requires that you pre-populate the Postgres data stores with all of its files and configurations and permissions and stuff like that. That actually is a little difficult to set up in Docker containers. You actually have to write some specialized scripts and write some specialized Docker files during your Docker build, to kind of temporarily start up Postgres to populate the Postgres cluster data in the var file system and stuff like that, and then shut it back down during the build process and store all of that in the layers.
So you wouldn't advise having a cluster of Postgres containers. You would rather say have one container that is a Postgres cluster.
No.
No. You would want.
No, we actually do run Postgres in Docker containers as a Postgres cluster with BDB, bidirectional replication and streaming.
Okay.
And we just mount the data volumes off of, in dev and staging we use NFS, in production we use InfiniBand and Fiber Channel. So we just mount that as a volume inside the Docker container, so that we're not using host I/O, we're using InfiniBand or Fiber Channel I/O.
Okay. Sorry. I'm trying to picture the map of. So there's a VM.
InfiniBand. Yeah.
InfiniBand's faster.
With two
Fiber
Docker
Channel
containers running Postgres independently, and then they're both mounted to the same volume.
Mm-hmm. Well, no. Not in our case, because we're using bidirectional replication. Each one has a separate data volume.
Volumes then communicating with
Correct.
the third Docker container, or are you just doing that on the host?
So we run multi-master Postgres using BDB. We actually have 6 nodes, 6 containers running across 6 separate physical hosts. And they all mount separate data volumes. 2 of those hosts are in remote data centers, and so they're specifically only backups in case the whole data center blows up or something, because we don't actually really access those databases ever. And we've got the streaming replication set up to be kind of lagging, so that it aggregates a bunch of updates together before sending them across we've got 100 gigabit Metro E MPLS connectivity between our data centers.
Fast. That's what I mean.
Really fast.
Yeah.
100 gig.
Sure.
100 gig across the continental U.S. That's expensive. It's hella expensive. And it's MPLS, and it's got redundant connections. So,
why pay for one when you can pay for 2?
Exactly.
Awesome.
So anyway, what I'm showing here on the screen, this is a Docker file that I just had our junior dev build to help him understand Docker. And one of the things he had to do is this install Postgres script that you see run down here near the bottom. This actually spins up Postgres temporarily, populates the cluster data, the lib files, and all of that, and then shuts it back down. And then when the container actually starts up, it moves all of that into the data volume, if it doesn't already exist, and then uses the data volume to do everything. Because Postgres won't start until you've populated all of that information.
That's really only important the first time you spin it up, right? You're going to persist the data volume.
Right. It's really only now, the other way we've done it in other systems is we use this start script. It's just a bash script that does whatever pre-configuration we need the first time a container starts up. It checks, say, are all of my data volumes soft-linked? If not, soft-link them. Are all of my pre-population stuff there, like is my Postgres cluster DB and basic files set up? Is my pghba.conf file set up? Things like that. We do that in that script, and that script executes supervisor D to start up the service that we want to keep running.
Back to your question from earlier about like the whole Docker file versus Docker image thing. So if you were to hand over a Docker image to production that's like 600 meg, and they need to ship it over to China or whatever, like that's a lot of stuff that might have to go across the wire versus this is just like 6K.
Mm-hmm.
So it's a lot easier to be able to just deploy your applications anywhere, any cloud.
So, for example, I'll kind of show you a brief glimpse at one of ours back in SunGuard AS. Our Docker files, the way we build them for our microservices, is that during the Docker build, it actually compiles the application or packages the application into the container. So this is a Java microservice, and you'll actually see down here it has some ancillary stuff that's written in Node. It downloads and compiles that, and then it installs the JRE. Then it copies in my source code, and then here's the commands that actually compile the code. Then it copies whatever settings it needs inside the container. Then it runs the tests and installs it to the appropriate directories. So our Docker builds actually are our continuous integration scripts. So when we commit something, when we merge a pull request, we run Atlassian Bamboo. Bamboo sees that pull request has been merged. It grabs that repo and does a Docker build.
That's kind of how we're doing what we're doing right now for QA.
Mm-hmm. And the result of that Docker build is not only the Docker container that you can run, it's also the test results, the test coverage results, any integration test results, all get published as artifacts. And in the case of mine, it actually publishes the Java docs as well for the API.
In the container or outside the container somewhere?
So the scripts actually copy the results of the build out of the container, because if you don't, you would have to extract it from the container somehow. There are tools for extracting data out of a container's layered file system, but it's a pain in the butt. It's more effort than you want to go to. Technically, you can do a loopback mount of the AURFS layers onto your file system.
What do? You just SCP them out?
Yeah. Yep, we just SCP them out. All right, so we're at our time limit. The cleaning crew has to get in here and clean up. Thanks, everybody. If there's interest, let me know. We'll start scheduling for the next couple of months a small segment of Docker to be continued, if that's what you guys want to do.
Docker orchestration.
It is a good thing I went first.
Thanks for coming, folks.
Yay!
Yay.
I have a